Uh, I am Dr. Taposi, presenting the interesting topic from programming. So programming, that means it is somehow related to program and doing program, writing programming. So swarm programming is automatic programming plus swarm intelligence. Now, my contents: introduction, automatic programming, genetic programming, grammatical evaluation, swarm intelligence, swarm programming, and applications. So we have prerequisites of genetic programming, grammatical evaluation, which is the backbone of swarm programming, and after that swarm intelligence, and finally we will move to swarm programming and then applications. Swarm intelligence is an emerging field of artificial intelligence that takes inspiration in the collective and social behavior of different groups of simple agents. The automatic evaluation of programs is an active research area that has attracted a lot of interest and has been mostly promoted by the genetic programming paradigm. The main objective is to find out a computer program from a high-level problem statement of what needs to be done without needing to know the structure of the solution beforehand. Swarm programming is the intersection between swarm intelligence and automatic programming. The automatic programming algorithms that use an SI meta heuristic as a search technique. So automatic programming, computers that program themselves, science fact or fiction. Now let the machines learn to write programs by themselves. So this is the automatic programming. So first of all, we will discuss a problem. The problem is called famous problem, Santa Fe ant trail problem. So it is a 32 by 32 grid, and in that grid there is 89 pieces of food in the trail. So trail is in the blue color, trail. Okay. So ant is in the top left corner of that grid and facing the first food. Now ant can move forward, so one step, can turn left, right, and it look ahead whether in front of the grid there is a piece of food or not. If there is a piece of food in front of it in the front grid, then it will eat the food, that piece of food, if there is move instruction. So each of move left and right takes one time step. Now the objective is to write a computer program for that ant so that ant can eat all of the piece of food, 89 pieces of food, in the predefined time step. Generally we use the time step 600. So how can I do that? We will not write the program by ourselves and then we embed that coding into that ant. No, we will not do that. We will develop a system. That system will generate the computer program for that ant, and when that program will be embedded into the ant, that by the help of that program, ant can eat all the piece of food in the trail, in the grid. Now, the prerequisite, the backbone is genetic programming. So genetic programming is a technique pioneered by John Koja, which enables computers to solve problems without being explicitly programmed. So genetic programming is an automatic programming technique. Okay. So genetic programming is to evolve computer programs automatically. It is a variant of genetic algorithm. We know that genetic algorithm is very much popular searching algorithm, global search algorithm. So it is a variant of genetic algorithm in which each genome is a tree data structure. In genetic algorithm, that each genome is a linear data structure, and linear data structure contain either binary or real coded value. But here in GP, each genome is a tree data structure, and tree represents a computer program in a specified language. Now, an individual in genetic programming is represented by tree, as I have said. Now, suppose this is a x plus then x and y. This represents a computer program x plus y plus 3. Another program is star slash y1 and division x2. So it represents the program y plus 1 star x by 2. So genetic programming is a population-based algorithm where multiple population is used and fast parallelly. And now there is three fundamental operations in genetic programming. First is crossover, another is mutation, another is selection process. So first in crossover, we try to understand the crossover process. So the parents are randomly selected by the selection process, and in GP crossover, we select a subtree in the first parent and select another subtree from the another parent, and then we exchange that. Okay, so here last tree that is selected. Okay, so x by 2. So actually this is a gray region is a selected tree. Okay, so here x by divided by 2 is placed. So the resultant tree is plus 3 division and x2. So it represents the code x by 2 plus 3. So in that crossover, we generate two new programs, computer programs. So parent is the original program. From the using crossover, we can generate a new computer program. Next is mutation. So this is the mutation. Suppose this is plus xy. So it represents x plus y plus 3. Now that mutation point 3 is selected. So what is the mutation process? In mutation process, we randomly generate a subtree, and then 3 will be replaced by that subtree, and the resultant tree is that, the offspring. So in place of 3, that star is added, that subtree is added, and the resultant tree is x plus, resultant program is x plus y plus y into x divided by 2. So by using mutation, we can generate another program. This is a flowchart of genetic programming. First generation equal to 0. So this is the basic flowchart building block of the genetic programming. So first we create the random population of a size, suppose 5,000 population size, and termination criteria made. Then we exit. Otherwise, we will do the operations. Evaluate fitness of each individual population. So each program is evaluated on the training data set, and it will return a fitness value. Then we have two probability. One is a crossover probability, another is mutation probability. Using crossover probability, we crossover and generate new solutions, and using mutation probability, will produce a mutant solution and evaluate it. So this will be iterated. For example, suppose 1,000 generation or 2,000 generation, and after the end of the run, we will get a base computer program. Okay, so we'll give the example later on, the evaluating program. Now application of GP, algorithm designing art. So painting, suppose painting, artificial painting, artificial music. To generate artificial music, genetic programming used. It is used in biotechnology, computer graphics, computing, control, process, robots and agents, spacecraft, optimization, data mining, electrical engineering, financial, hybrid systems, image processing, modeling, natural languages, pattern recognition, and signal processing, and so many applications also there. So if anybody can study, want to study GP, genetic programming, so these are the valuable books, very useful books, genetic programming on the programming of computers by means of natural selection. It is run by John R. Koja, the developer. Genetic programming part 2, automatic discovery of reusable programs, John R. Koja. Genetic programming and introduction, Wolfgang Benhab. This is a very good book also for introduction. A field guide to genetic programming, Ricardo Folli et al. So these books are very helpful to study about genetic programming. Now grammatical evaluation. So grammatical evaluation, so that means grammar comes into the picture. So grammatical evaluation is a variant of genetic programming. It is developed by Michael O. Cunell and Conor Ryan, University of Limerick, Ireland. So in what we have seen that in GP, that is a tree structure, non-linear data structure is used. Okay, but in grammatical evolution, linear genome is used instead of tree data structure genome. Linear genome is an array of integer codons in the range 0 to 255. So here a linear genome consists of the value in the range 0 to 255, round value, not float, it is integer value. Now, metasyntax back-up form of context-free grammar is used to map phenotype, that is a computer program, from genotype set of codons. So here we have to define the problem-specific context-free grammar in back-up form. Now, this is an example. First grammar, S is a start symbol expression, and non-terminal, there is expression, operand, pre-operand, variable, terminal cost, plus, minus, division, multiplication, and the variable, and represented by the following rules. P. So expression equal can be replaced by expression of expression, pre of expression, variable, and of can be replaced by plus, minus, division, and multiplication. Pre of can be replaced by cost, and var can be replaced by either y or a constant 1.0. In the right hand side of that expression rule choices, so there is index 0, 1, 2. So these are the choice numbers. So for rule 1, for expression, we have 3 choice. We can replace expression by 3 alternatives. So that's why choice number is 3 in the table. And for of second rule, there is 4 options: plus, minus, division, and multiplication. For rule number 3, we have only 1 choice, that is cost. And variable, we have 2 choices, either y or 1.0. Now the second, so first of all, we have to define problem-specific context-free grammar in back-up form in BNF. Then we have to map. How to map from that integer set of codons to computer program? So rule is index of the production rule is equal to codon mod number of rules of the current non-terminal item. Now here is an example is given. Expression. So expression is equal to, so first 1550. So 150 mod 3. So it will be 1, not 120, it will be 150. Okay, because the codon is 150. So it is mod by 3. Rule is choice is 0. So here the first expression is replaced by expression of expression. The index is 0. So we choose the first rule, and expression is replaced by expression of expression. Then we are performing leftmost derivation. Then expression. So next 137 mod 3. It has 3 rules. So it is replaced by var. In that way, we replace all the non-terminals by terminals, and we are getting y plus 1.0. So this is an example of the derivation process. So we can generate the computer program from the linear genome to a computer program. Okay. So next, grammatical evaluation. So here also genetic algorithm used as search algorithm or learning algorithm. So what is the role of genetic algorithm here? Genetic algorithm just modify or create new solution from the linear genome. A new solution it will represent, and a solution, if a vector don't change, then the corresponding computer program is also a new program. We are getting new computer program. So genetic algorithm just searching the optimal set of integer codons, and from that we can get optimal computer program. So very good book is Michael Funnell, Conor Ryan, Grammatical Evolution, Evolutionary Automatic Programming in an Arbitrary Language, Springer US. There is another also a very good book, 20 years of grammatical evolution of O'Neill. So it will be a very good book. So it basic building blocks and different types of applications are there in that book. 20 years of grammatical evaluation. Now swarm intelligence. So swarm intelligence used for optimization. Okay, we are following the phenomena, natural phenomena of the species in the nature. So first is flocking of birds. Modeling that pure particle swarm optimization algorithm is designed by John Kennedy. on in 1995. Then honeybee. So their honey collection mechanism is modeled by artificial bee colony algorithm, the Darvish Paravoga. Then ant colony optimization technique. So the collection, the optimal pathfinding by the ant. So that is by uh, modeled and it is developed. The one algorithm is ant colony optimization that is developed by Mark Dorigo. So that algorithm, one real life application is that HP router. In the network we are using router. So HP router use are using that ant colony optimization to find out the shortest route. Then cuckoo shot, then modeling the gray wolf, their collection, food collection. So gray wolf optimization, eagle optimization, mushroom optimization, whale optimization algorithm, grasshopper optimization algorithm. So we are actually following, mimicking the behavior of the natural species, and we are finding the solution. Now this is a list of the some maintenance algorithm well known. Okay, so ant colony optimization, artificial bee colony, cuckoo search algorithm, mushroom optimizer, whale optimization algorithm, gray wolf optimizer, grasshopper optimization algorithm, slime mold algorithm, salt swarm algorithm, multiverse optimizer, water spider algorithm, marine predators algorithm, sine cosine algorithm, fireworks algorithm. So fireworks algorithm, it is modeled by the fireworks in the sky in the night. So this fireworks algorithm is also popular. It is developed by White Cat from China, and the list of most of the combination algorithm recently developed by S. Mirjili. So there are so many optimization algorithms. Dragonfly fly optimizer also there. So now swarm programming, we have already said that swarm intelligence in automatic computer program generation. Its objective to generate computer program automatically in any arbitrary target language. Arbitrary target language means if I want to generate the code in MATLAB, so it will generate the code in MATLAB. It can generate code in C, in Java, in Python, whatever. Whatever I set the target language, accordingly it will generate that language, generate that computer program in that particular target language. Now we will discuss two swarm programming algorithm: artificial bee colony programming and grammatical bee colony. So why I have selected that two algorithms, because these two algorithms uses use two different strategies. Okay, so artificial bee colony algorithm is used in artificial bee colony programming to generate the computer programs. That algorithm is developed by Darvish Paravoga, the inventor of the artificial bee colony algorithm. So he developed that artificial bee colony programming. So ABC, based on the behavior of honeybees, both ABC and ABCP, that is artificial bee colony programming, is developed by Darvish Paravoga. And ABCP, each solution is a tree representing a computer program. So here, like genetic programming, here is also each solution, that is a search agent, is a computer program. So it is a tree data structure. It is used. Okay. So it is developed to solve the symbolic regression problem. So its objective was to solve the symbolic regression problem. So now this is the algorithm of artificial bee colony algorithm. Artificial bee colony algorithm two phase: work phase and the onlooker phase. So worker phase, in the worker honeybees move and they are search the solution nearby by the neighborhood and collect the information and come to the beehive. And how they convey the information to the onlooker? They are just speeding anti-clockwise in a high speed. So by that symbol, the others can understand that okay. So it has the information, that bee has the information of the maximum honey in the food source, in the source. So you can suppose this is the algorithm. Okay, first we search the neighborhood and modify, generate a new solution, then calculate the probability of the fitness, and depending on that probability, we are selecting onlooker select the current solutions and generate new solution, evaluate that, and that is going on for a cycle. So this is an algorithm. Now information sharing, how information is shared, that is similar to crossover operations. So just like not actually like crossover operations, but similar. So in A, this is a one food source. Okay. So in B, there is another food source, and so plus is selected, plus 1 1, and sign plus XX. So that sign plus XX information is taken, and it is given in that plus. So so in place of plus, we place that subtree. The sign plus resultant is B. So 1 star plus 1 x. So sign plus x. So from the root, we have to visit from the root. So plus star star, and from star 1 sign plus x. So actually in that subtree, the resultant expression is 1 into sign of x plus x, or that is sign of 2x. So in that way, it shares the information and generates a new solution. So this is the main mechanism here. So grammar-based swarm programming. So if we use grammar, context-free grammar in swarm programming, then it is called grammar-based swarm programming. So it is developed by O'Neill. So grammatical swarm, this is the following reference paper. You can study details in that paper. So I just want to say that grammatical swarm, the same philosophy like grammatical evolution. In grammatical evolution, genetic algorithm is used as search engine. In grammatical swarm, particle sum optimizer as search engine or learning algorithm in genotype to phenotype mapping. And then grammatical B colony. So grammatical B colony is developed by myself. The paper is published in that paper below. So grammatical B colony, so artificial B colony as search engine, and in genotype to phenotype mapping. So artificial B colony algorithm is used here, but here a linear data structure is used. Okay, from the integer set of integer codons, the program is evolved. Now grammatical fireworks algorithm. This grammatical fireworks algorithm is also developed by myself in 2016. So fireworks algorithm as search engine in genotype to phenotype mapping, it is used fireworks algorithm. So now we discuss the POSO as a search engine. So this is a flocking bird. Okay, in the two pictures. So in POSO there is each agent can memorize its own personal base, and by personal base and global base, inclusion of by these two terms and its own position, they change the location and move to the new direction. So this is a flowchart of the POSO algorithm. So initialize parameters of POSO, evaluate the fitness, update personal base and G-base, update velocity and position of each particle. Transmission criteria satisfied, yes, then stop, otherwise continue. Now grammatical B colony. Artificial B colony algorithm is used to generate the computer programming. It is linear array of integers in the range 0 to 255 as search agent. DNF of CFG is used to map the programs from the search agent. So now benchmark problems. We want to solve some benchmark problems. Santa Fe Antel problem. For that we have to define the grammar in backup form first. So code equal to code line. So this is the grammar defined. So there is if else condition is also there. Okay, there is the operation left, right, and move. So this is a grammar for defined for Santa Fe Antel problem. Symbolic regression problem, x plus x square plus x cube plus x to the power 4. So this is the grammar. The second grammar, expression equal expression of expression var. So we also solved even three parity problem. Expression, this is the or, and, not, NAND. So this is the Boolean. This is the logic, digital logic gate, and input is 3 inputs. So there is x1, x2, x3 3 variables. So similarly, 3 multiplication grammar also. So now, so first we have discussed about Santa Fe Antel problem. What is our objective? Our objective is to design, develop the program, generate the computer program automatically. The system return that program. Okay. So in that, using that program, and it's only 64 pieces of total 89 pieces of code. It can eat all 89 pieces of code. So it is that program is generated by the GBC, grammatical B colony. Now regression analysis, this is the computer program for plus p divide is a protected division, plus times. So this is the expression. If we solve that, they will get x square x plus x square plus x cube plus x over 4. Even p problem, this is the expression we are getting, and three multiplication problem, absolute error 0. But here even problem, there is absolute error 1. So this is a successful program. Three multiplexer problem is successful program, and regression problem is a successful program. Now, grammatical fireworks algorithm generates that program that, and it's all 89 piece of code. So if I using that program, so it actually that program will be inducted in a loop having the condition, the termination condition 600 times safe, or and it's all 89 piece of code. So that code should be placed inducted in a while loop, and that program will be run, and using that program, the and it's all the 89 piece of code. This is a successful program. Now grammatical fireworks algorithms generate the result program plus times. So this is the expression for the regression. Three multiplexer problem, NOR and x1 x2. So in that way it generates the program. The absolute is 0. So it is they are all successful programs. Now one application from grammatical B colony I want to discuss. So image segmentation, brain MRI segmentation for lesion detection. So first we pre-process the image. So I am going to the main part, that is the flow chart. So grammatical B colony used here as a classifier system. So first we have extract the features from the using SWT, stationary Euler transform, and using that feature we use the grammatical B colony classifier and train the classifier, and then we test it on the testing data set, and final result is a segmented lesson. So what we have to do, so this is a method. First we have to define the context free grammar. That means what will be the function set, what will be the terminal set. So for that to solve that problem, we have first defined the function set, that is plus, minus, division, multiplication, absolute value, absolute function, square root, log, exponential, sine, cos, and function in as we are writing the code in matter language. So corresponding that function set, we have the functions plus, minus, times, p divide, absolute, add, square root. So here c square root means we customize the square root, and p divide protected division. So customize square root means we can make square root of negative number, so that is protected. So p divide also protected division. So this is the grammar we have used. Okay, this grammar is used. So variable has number of variables is x1, x2, x up to xn. If the data set has x number of attributes, so we have to take the variable from x1 to xn. Next, so this is a derivation process. We have already discussed that how to derive the program from the linear genome, integer set of integer codons. We have already discussed that. So this is the classifier main theme. So here we will design two computer programs. Okay, so that entire linear genome is partitioned by two. There is two groups. One first group will generate the first program. Second program will generate the second program, and then there is a function that will not take all policy is adopted. That means if the first program gives the better result than the second program, then the first class level will be that first program wins, and the class level will be 1. If the second program wins over first program, then the class level will be 2. So this is a function of z. Fine. So now, so this is a block diagram of the schematic diagram. So first, the set of integer codons are divided into groups. So in that program, in that problem, we have two class. So that is two groups. If there is a multiple class, then we have k number of multiple class. Then we have k number of groups, and from that we can derive the k programs using the context free grammar. So this is the result. How do we measure the result? So we have found that grammatical B colony performance better than other algorithms. So this is the Gaussian mixture model generate the first result, and this is a grammatical B colony with almost accurate segmentation uh, result is written by the grammatical B colony. So two programs evolve. So first program is cos, this is the expression, and second program exponential minus x8 x5. So now here we can observe one thing is that we have suppose x1 to x16. So all the inputs are not used. Only here first program used only three variables x9, x11, x12. So three features have been used, and in program 2 it uses only two features x5, x8. So what is the point is here? It also can perform automatic feature selection. So it can also perform feature selection. This is the important research area, feature selection. So grammatical B colony can also select the useful features from the data set. So thank you. Any questions?
Thank you, sir, for your presentation. I would request if the audience members have any questions, then they can post it in the chat box. I would request the audience members to post their questions in the chat box. I think we have the first question here, which is better among GA and SI. It's a question by Amrita Yadav, Miss Amrita Yadav.
Okay. So there is one theory in optimization, that is no free lunch theorem. So what is the point of no free lunch theorem? That one algorithm cannot provide better solution for all class of problems. So genetic algorithm can provide uh, better solution for some problems on some set of class of problems. On the other hand, particle sum optimization can give better solution on some other set of problems. So this is a no freelance theorem, but of course one advantage is there. PSO is much faster than genetic algorithm. Genetic algorithm is time consuming, but PSO is much faster than genetic algorithm.
Thank you, sir, for answering this question. If there are any more questions, then the audience members are requested to post them in the chat box, please. So I think we can wrap up the Q&A session. I don't think any more questions are forthcoming. So thank you, Dr. Tapasri, for sharing your thoughts in this very interesting topic of swarm programming. I'm sure the audience members have greatly benefited from your presentation. Thank you for being here today, sir.
Thank you, ma'am. Thank you
Thank
all.
you, sir. Before we move on to the next keynote speech of the day, I would like to introduce few members of organizing committee of GCAIA 2020. So first, I would like to invite Professor Dr. Aniruddha Mukherjee, Dean of the University of Engineering and Management, Jaipur. Dr. Mukherjee has always been keen on fusing industry requirements in academics. He spent almost 8 years in the engineering industry soon after his graduation from NIT Silchar and has been associated with the installation and commissioning of some of the prestigious power plant projects of the country. A postgraduate from Jadavpur University, his research area was in evaluation of parameters involving life estimation of light sources. His current field of interest includes power quality, lighting designing, and engineering. Now I would request Professor Mukherjee to deliver his welcome address to the audience. It's over to you, sir.
Thank you very much, and a warm welcome to all the honorable keynote speakers present in this session. It has been a privilege and an honor from all of us to have all the keynote speakers on board. And this conference will definitely, I would say, it is a confluence of various ideas, and each ideas will usher in into a new dimension of development. The topic, as I understand from the conference, is about the artificial intelligence. Now, it might not be out of place to mention that artificial intelligence is a technology that is transforming every walk of life. It is a wide-ranging tool that enables people to rethink how we integrate into information, analyze data, and use the resulting insights to improve decision making. Or we hope through this comprehensive overview of the conference will enable us to explain artificial intelligence to the policymakers, the opinion leaders, and the interested observers, the researchers. In this conference, so far, I was privileged enough to attend a few sessions where there was quite a few noble applications in education, agriculture, and a lot of other avenues of development. Artificial intelligence algorithms are also designed to make decisions, often using real-time data, and they are unlike passive machines. They are capable only of mechanical or predetermined responses. Uh, it has got the ability to learn and adapt to make decisions in the transportation area also, which is very important because nowadays we must take into consideration of the possible impediments of the traffic impediments primarily by introducing the semi-autonomous vehicles. Now, it might not be also out of place to mention that it is not certainly a futuristic vision, but rather something that is here today and being integrated with and deployed into a variety of sectors. This includes fields such as finance, national security, health care, criminal justice, transportation, smart cities. There are numerous examples where artificial intelligence is ready and making an impact on the world and augmenting human capabilities in significant ways. I believe this conference will definitely put forth noble ideas and concepts so that we, as an human being and as a mankind, could progress further towards the development. Thank you so much. I wish all the best for all the presenters and the delegates present here.
Thank you, Dean Sir, for these sage words of wisdom. This conference has seen the light of the day with your guidance and encouragement.
Thank you.
Thank you so much,
Thank you
sir.
so much. Thank you so much. Thank you.
Next, I would like to invite Professor Dr. Pradeep Kumar Sharma, Provost of UM Jaipur, for his address to the audience. A recipient of Outstanding Teacher for Excellence Award in Academics by Institute for Technical and Scientific Research Foundation in 2017, and Rashtriya Shiksha Gaurav Puraskar from Center for Education Growth and Research in 2018. Dr. Sharma is also a life member of Indian Society of Technical Education. He is a board member of International Journal of Engineering Research and Science, as well as International Association of Scientific Innovation and Research. A reviewer of International Journal from Science Publications, American Journal of Applied Science, and Journal of Computer Science, Journal of Optical Engineering from SPIE, and Kuwait Journal of Science, Professor Dr. Pradeep Sharma has published more than 14 research papers in reputed journals and is the author of around 12 books on engineering physics, electronics materials and processes, and spectroscopy, to mention a few. Now I would request Professor Sharma to deliver his address to the audience. It's over to you, sir.
I hope I am audible.
Yes, sir, you're audible.
Okay, thank you. A very good morning to all present here. So first of all, I would like to thank our Chancellor Sir, Vice Chancellor Sir, Pro Vice Chancellor Sir, Registrar Madam and Dean Sir for providing the suitable environment for this conference. Global Conference on Artificial Intelligence and Applications. Professor Somen and his team worked day and night to make this conference a success. The significant characteristics of this conference is the promotion of inevitable dialogue between scientists, researchers, engineers, corporates, and scholars, students, to mitigate the gap between academia, industry, and government ethics. This motivation is fostered through keynote speeches, tutorials, exhibitions, and oral presentations by eminent researchers in relevant field. And many of the experienced persons are here as keynote speakers, and definitely the researchers are providing a very valuable material to the conference. Let me discuss something regarding this subject also. Artificial intelligence refers to the ability of machines to perform cognitive tasks like thinking, perceiving, learning, problem solving, and decision making. Initially conceived as a technology that could mimic human intelligence, AI has evolved in ways that far exceeds its original conception. With incredible advances made in data collection, processing, and computation power, intelligent systems can now be deployed to take over a variety of tasks, enable connectivity, and enhance productivity. As AI capability have dramatic uses, and there are different expansions, so have its utility in a growing number of fields. The truly transformative nature of this technology, yet the nascent stage definitely of its adoption worldwide, provides India with an opportunity to define its own brand of AI leadership. As given by the Niti Aayog, hashtag AI for all, the brand proposed for India implies inclusive technology leadership, where the full potential of AI is realized in pursuance of the country's unique needs and aspirations. The strategy should strive to leverage AI for economic growth, social development, and inclusive growth. And finally, as a garage for emerging and developing economies. While AI has the potential to provide large incremental value to a wide range of sectors, adoption till date has been driven primarily from a commercial perspective. Technology disruptions like AI are once in a generation phenomena, and hence large-scale adoption strategies, especially national strategies, need to strike a balance between narrow definitions of financial impact and the greater good. Niti Aayog has decided to focus on 5 sectors that are envisaged to benefit the most from AI in solving social needs. Number 1, healthcare, to increase access and affordability of quality healthcare. Second, agriculture, enhanced farmer income, increased farm productivity, and reduction of wastage. Third one is the education, improved access and quality of education. Next one is the smart cities and infrastructure, efficient and connectivity for the burgeoning urban population. And last one is the smart mobility and transportation, smarter and safer modes of transportation and better traffic and congestion problems. But truly to reap the benefits of developing AI at this scale, there are certain barriers that need to be addressed in order to achieve the goals of hashtag AI for all. Lack of broad-based expertise in research and applications of AI, absence of enabling data ecosystem, access to intelligent data, high resource cost and low awareness for adoption of AI, and privacy and security, including a lack of formal regulations around anonymization of data. And last is the absence of collaborative approach to adoption and application of AI. Superior research capabilities have been the cornerstone of leadership aspirations in emerging technologies, and effectively realizing the growth potential requires expertise in both core and applied research. Despite indication of recent positive efforts in this aspect of technology, AI research in India is still in its infancy and requires large-scale concerted and collaborative interventions. For that purpose only, this conference, I think, plays a major role, where we have received almost, you can say, 336 research papers on this topic, and the acceptance rate is 32.14%, 108 papers being accepted. And you can understand that the leaders of academia and leaders from the corporate are here as a keynote speaker, from Dr. Christopher Nugent from Ulster University, UK, Thomas Poiter, CEO of Compressed Technology, and many more. But I have just to mention a few names like Dr. Srinivas and then Dr. D.P. Kothari, who has given, you can say, very insight into the topic and um, given guidelines and guidance for how to conduct these kind of things and how to do the research in our universities. I welcome all the keynote speakers into this conference, and I wish best of luck for all the presenters to have a success in this conference and all, and further conferences also and further research area. But try to improve the AI part in India as far as the applications of AI in education as well as in smart cities are there. Thank you. Thanks a lot.
Thank you, Provost sir, for your inspiring words. Your constant support and encouragement has helped UEM Jaipur to organize this conference. Thank you, sir. Our next speaker is a dynamic, result-oriented professional with blend of data science, analytics consultancy, business analytics, and project and people management experience, comprising 17 plus years from project scoping to entire execution in several successful shared services organizations in India in technology, consumer goods, CPG, retail, travel, hospitality, and MLU sectors. Please join me in welcoming Ms. Anchanita Das, Associate Director, AI and Analytics for Digital Business, RCGTH and MLU for Cognizant Technology Solutions. Ms. Das has a rich experience in formulating and implementing light listening, deep listening, loyalty analysis, comparative landscape analysis, and sentiment prediction models using social media data for different brands or domains. She has also worked in marketing media spend as well as channel optimization. Some of her specialities include CRM, business intelligence, predictive modeling, pricing analysis, discriminant analysis, and forecasting. Now I would like to invite Ms. Anjanita Das to please start her speech on AI and ML journey and future of data science. It's over to you, Ms. Ma'am. Ma'am, you're not audible.
Good morning, everybody. I am audible now?
Yes, ma'am. Now you're audible.
Okay. I'm just sharing my screen. Let me know when it is up.
Yes, sure, ma'am.
You are able to view my screen?
Yes, ma'am. We are able to see your screen. Yes.
And my voice is clear?
Yes, ma'am. It's clear, loud and clear.
Okay. Good morning, everybody. I'll start with little intro about myself. I'm Anjanita. I have around 17 years of experience in analytics and data science. And today I'll talk about AI and machine learning journey and future of data science. The intention of this presentation or this session is not to take you through any particular technique or methodology. Rather, I'll talk about different use cases which you may which you are seeing in AI/ML space now and which you will be seeing in the near future. So broadly, I'll be covering this topic like AI/ML journey, types of AI, types of ML, automated machine learning, why AutoML is required, AutoML framework, how AutoML work, will AutoML be the end of data scientist, AI/ML potential for business across the globe, future of data science, AI and ML, and importance of combining human intuition and machine learning. To start with the AI/ML journey, artificial intelligence is well accepted and widely used in the business applications. Now the industry leaders, they understand the AI value and expect the gain in the area of optimizing business process, maximizing ROI and minimizing cost. Over the decades, AI has evolved and gained more and more importance. And most of the recent, you might have already observed that most of the AI application are consumer centric. You are already aware of Apple Siri and Amazon Alexa. They are being quite popular in the market. Now we use AI and machine learning terms interchangeably, but please remember that machine learning is a subset of artificial intelligence where computer algorithms are used to autonomously learn from data and information. Now, why do you think AI/ML is becoming so popular nowadays? Now we have tremendous amount of data. They are being generated in the form of text, images, videos, as well as through IoT devices. We have lots of advanced algorithm now in the form of deep learning, machine learning, which require lots of computer processing power as well as storage. And because of Moore's law, the cost for both of these has come down. Now, to talk about AI and machine learning journey, the journey of AI and machine learning can be divided into three phases: birth of AI/ML, AI winter, and evolution of AI and ML application. John McCarthy, the father of artificial intelligence, has coined the term in 1956 and defined it as science and engineering of making machine intelligent. AI and ML have progressed significantly over the decades. Let me take you through few of the highlights across the timeline. The first case of neural network was observed in the year 1943 when neurophysiologist Warren McCullough and mathematician Walter Pitts wrote a paper about neurons and how they work. They decided to create a model of this using electrical circuit, and therefore the neural network was born. Then in the year 1944, John von Neumann introduces game theory. Using game theory, many real-world problems like price increase, competition and product releases, then dictator game, prisoner dilemma can be solved, and their prediction can be their outcome can be predicted. In 1950, Alan Turing created a test named Turing test, and this is a fairly simple test for a computer to pass. It just has to able to convince a human that it is a human and not a computer. In 1952, Arthur Samuel created first computer games that played checkers. And another early instance of neural network came in 1959 when Bernard Windraw and Marcian Hoff created two models, Adeline and Madeline. Adeline could detect a binary pattern, whereas Madeline could eliminate the echo on the phone, and therefore it is having a real-world implication. In the year 1961, there was a revolution in manufacturing world with the introduction of first industrial robot Unimate and General Motors. They have jumped ahead of its competition to become the first automated automotive plant in the world. In 1969, it rebuilds its Ohio farm with Unimate spot welding robots. Then there came ELISA. ELISA is a natural language processing computer which introduced sometime in 1964 to 66. Then there came first general purpose mobile robot Shweki in between 1966 to 72. While other robots would have to be instructed on each individual step of completing a larger task, Shweki could analyze the command and break the task into two basic chunks by itself. But despite of the success of Madeline, there was not much progress in ML space until late 1970, partially due to the popularity of von Neumann architecture, where instruction and data can be stored in the same memory, which is arguably simpler to understand. In 1982 is the year when the interest on neural networks started picking up again, and neural network with back propagation came into picture. In late 1980s and early 1990s, we have not seen much in the space of AI and ML, and this phase is known as AI winter. Now, in 1997, IBM introduced Deep Blue, which is a chess playing computer and which beat the world chess champion. And since then, there have been many more advances in this field, such as digit recognition by AT&T, Bell Laboratories. Then there came the robot Kismet in 1990, which can simulate emotion. Then Sony Corporation, they introduced their robotic dog Aibo in sometime in 1999. Then there was introduction of robotic vacuum cleaner by iRobots in the year 2002 named Roomba. In 2000, during 2006 to 15, there was introduction of autonomous car. Then Apple introduced Siri in the year 2011. Then IBM introduced Watson, a question answering computer system. Then Amazon introduced Alexa in the year 2014. Then Google Brain was introduced, AlexNet came into the picture. Then there was introduction of DeepFace. DeepFace is a neural network developed by Facebook, which can recognize the people with same precision as human can. Then another interesting thing, Amazon machine learning platform AWS introduced in the year 2015. In 2016, Microsoft introduced its chatbot TAY. Google introduced AlphaGo, which is a computer program that plays board game Go. Then there was introduction of Sophia, a social humanoid. Then there was introduction of Google Duplex, which is quite interesting. It is an AI system for accomplishing real-world tasks over phone, and that has been introduced sometime in 2018. Then there was lots of improvement in the GPU space, like NVIDIA TensorFlow, Google Tensor Processing Unit, etc. Also, AutoML introduced sometime in 2017. Today, AI/ML is widely accepted in the business across the domain, and researchers are hopeful to progress towards strong AI. And now we can see lots of practical uses of AutoML. Now I'll talk about types of AI. Artificial intelligence is broadly categorized into three types based on nature of work: narrow AI or artificial narrow AI, general AI, strong AI or artificial general intelligence, superhuman intelligence or artificial superhuman intelligence. Now AGI and ASI are the future state of AI. Now what is narrow AI? Weaker AI or narrow AI refers to the machine or software that can focus on one narrow or specific task. Now there are two types of narrow AI, reactive machine and limited memory. Reactive machine do not have memory and response to what they see. For example, AlphaGo, IBM, Deep Blue, etc. Limited memory system have the ability to look into past experience to inform future decision. For example, self-driving car, image classification, machine translation, etc. Currently, LMs are widely used in business for automation, improving productivity, and gaining predictive insight. The future of AI are AGI and ASI. The strong AI or artificial general intelligence has the ability to learn, solve, and perform any task that is presented without any human intervention. And ASI or superhuman intelligence refers to the cognitive ability of machine learning that can do everything that human can do or even more. Self-awareness is the idea of AI that has the ability to understand its surrounding and will have sense of self-consciousness and use that information to further understand what other human or machines are feeling. Now I'll talk about types of ML. There are four types of machine learning: supervised machine learning, unsupervised machine learning, semi-supervised learning, and reinforcement learning. Supervised learning is possible when you have a target variable. The target variable can be continuous or categorical. The supervised learning algorithm try to model relationship and dependencies between the target prediction output and the input features. Now, the common algorithms could be nearest neighbor, naive-based decision trees, linear regression, SVM, or neural network. Unsupervised learning we do when we don't have any target variable. So we have to train the unlabeled data, and this can be clustering or association both. For clustering, you can think of k-means clustering. For association, it could be market basket analysis. Now, semi-supervised learning is something which falls in between supervised learning and unsupervised learning. There, in many practical scenarios, the cost of labeling the data is quite high because that is requiring the experienced human labor. And that's where semi-supervised learning is the best candidate. It can be classification and clustering both. For classification, you can think of text classification. For clustering, you can think of lane finding on GPS data. The last one is reinforcement learning. Reinforcement learning method aims at using observation gathered from the interaction with environment to take the action that would maximize the reward or minimize the risk. Reinforcement learning is a type of machine learning and thereby also a branch of artificial intelligence. The common algorithms are Q-learning, temporal difference, deep adversarial network, etc. Some of the application of reinforcement learnings are computer played board game, robotic hand, self-driving car, etc. Now I'll talk about AutoML. What is AutoML? As the name refers to, it automates the end-to-end process of applying machine learning in real and practical scenarios. We have observed the trend of AutoML sometime, I think, first quarter of 2017. Now, if you are aware about the data science process, the first step is to reading or merging data. Then it comes to pre-processing. Then it comes to optimization, that is feature selection, feature engineering, model selection, and then application, that is prediction and model interpretation. Now, AutoML can automate any intermediate steps other than the data collection, prediction, and interpretation. Now, the AutoML mainly falls into three categories: AutoML for automated parameter tuning, which is a basic type; AutoML for non-deep learning, for example, AutoScaler; AutoML for deep learning or neural network, that includes neural architecture search or efficient neural architecture search, or as well as you can think of AutoKeras. Now, why AutoML is needed? AutoML is needed to improve the efficiency by automating the repetitive tasks, and this allows data scientists to focus more on problem instead of models. Also, automated ML pipeline also help to avoid potential error, because you are automating the repetitive task, so there is a less chance of having manual error. Now, AutoML is a big democratization towards which allows everyone, even the non-expert, also to use some of the ML features. Now, there are many AutoML implementation services like Amazon SageMaker, Azure Machine Learning AutoML, Google Cloud AutoML, Data Robots, etc. Now, I'll talk about AutoML, some of the AutoML framework which are quite popular in the market. The first one is Teapot, that is tree-based pipeline optimization tool. It is a Python automated machine learning tool that optimizes machine learning pipeline using generic programming. Then AutoScaler, this is an automated machine learning package based on scikit-learn. Those who are familiar with Python may already know that it is a replacement of scikit-learn estimator. Then there is AutoKeras. It is an open source software library for automated machine learning. Then there is something called MLBox. It is a powerful automated machine learning Python library. And according to the official document, it provides first reading, distributed data, pre-processing, cleaning, formatting, feature selection, etc. Then the next one is Neural Network Intelligence. It is a toolkit for Microsoft to help user design and tune machine learning models. Now, if you are aware about end-to-end statistical modeling process, we need to start with raw data. Then we need to do data cleaning, then feature selection, feature processing, feature construction, model selection, parameter optimization, model validation. Here I have taken example of Teapot. Teapot can automate feature selection, feature pre-processing, feature construction, model selection, and parameter optimization. But there are few points to remember. If you want to apply machine learning algorithm, you need to make sure that you have the cleaned and summarized data. You have done the data consolidation. You have cleaned the data and processed the data. You have done the required transformation. And also after you get the model output through ML, you need to validate it. And deployment also you need to do it. And it is advised to have a quick and dirty model before you start the ML process so that you can have a benchmark to compare. Now, AutoML can do so many things. So do you think AutoML be the end of data scientist? Uh, AutoML does not definitely spell the end of data scientists. The biggest shortcoming of AutoML is that it has no business intuition. AutoML will get you to a production-ready model more quickly, but it won't tell you why to use ML or what the business justification is. If you have a series of business problems, AutoML cannot select the business problem on its own. Now, let's say you select a business problem based on your gut feeling and you have not involved data scientists in that process. Also, you have aligned your different stakeholders without involving your data scientist, but still you need a data scientist because AutoML cannot select the data on its own. You need to figure out the training data. So for that, definitely you need data scientist. Now assume you have select a problem, align stakeholder and find indicative data. After building our model, we can easily run into problem of bias. Humans are inherently biased and is reflected in data we output if we blindly train the model on biased data. Then our model will also be biased. This was clearly seen in Amazon's sexist recruiting algorithm or Google's racist image classification algorithm. Furthermore, once the model is ready, it is still have to be integrated into the rest of the platform by software engineers. However, the software engineers typically don't understand the limitation of AI because it is not their job. And you may end up implementing a faulty model if you don't involve your data scientist. Now, finally, suppose you have brought your model into production. A data scientist is the most likely individual to see the value add of the model, as they are the ones who champions on the same. And without any data scientist, you may mark the feature incorrectly and not understand what use case it truly signs. Now, I'll talk about AI/ML potential across the globe. Since the onset of digital era, the data is continuing to grow at an exponential rate. With every little sign of showing down, the constant influx of data acts as fuel for existing data science model, creating a breeding ground for improved data science model as well as creating and fresh, as well as getting a creative and fresh use cases. The global survey report says that the global software market is expected to grow approximately 154% year on year, reaching a forecast size of 22.6 billion USD in 2020. Moreover, PwC's Global Artificial Intelligence study says that 15.7 trillion potential contribution to global economy by 2030 from AI. Now, considering AI maturity and digital activity in the country and AI talent as parameter, the top 5 countries in the race are China, United States, Japan, United Kingdom, European Union. There will be more and more computer consumer and user centric application in AI/ML space in future, utilizing computer vision, natural language processing, voice processing, supply chain, and predictive maintenance. In the next few slides, I'll talk more about the use cases using these techniques. So the use of AI and ML in retail space grew 600% from 2016 to 2018. By 2023, it is estimated that 95% of the supply vendors in consumer goods space will be leveraging AI learning. The main area where we are seeing and we will see AI and ML application is in the customer service area. There will be more use of chatbot, virtual assistants. The customer service interaction handled by AI will grow by 400% in 2021. Now I'll talk about few examples. You already have heard about H&M. H&M is already using visual search where one can use the photos of their favorite items uploaded in H&M app, and it gives you a list of matching or similar items in the stock. Another interesting one is Brown-Forman created a custom chatbot to bring consumers whiskey education straight from the distillery. The Whiskey Whisperer has been introduced to help some of their legendary brands like Woodford Reserve and Jack Daniel to stand out on the shelf. The chatbot both educate as well as inspire the consumers, ultimately helping to simplify the whiskey selection process. Now, delivering unprecedented engagement and growth, the straight from the distillery program is a perfect, according to me, it is a perfect cocktail of insight, shopper strategy, innovation, and data science. Now, I think you already aware about Kohler Connect. So the next important area is cameras and robotics. Amazon Go is a new kind of store featuring world's most advanced shopping technology. There's no line, no checkout, just grab and go. This checkout-free shopping experience is made possible by the same type of technology that's been used in self-driving car, that is computer vision, sensor fusion, and deep learning. Now, few of the retailers like Target, Walmart, they are already using robots tracking their inventories at their store.
Ma'am, sorry for interruption.
Yeah.
Can you please wrap up your speech quickly, because we are already running late.
Okay, sure. So personalization is another area where you can see some traction, and some of the beauty giant, like some of the companies like Estee Lauder, they are using personalization in their servicing. Then supply chain, as I told earlier, supply chain is one of the area. Then predictive modeling is one of the area where you can see McDonald's, they are using lots of predictive modeling. Then there are areas like you can see, I mean, manufacturing industry is one of the industry where there is a huge potential of data science in future. So in manufacturing industry, whatever product you manufacture, you have lots of assets. So you can think of use cases like predictive maintenance, anomaly detection, customization, demand forecasting, other premium service that could mainly post-sale service, then new revenue stream, that is cross-sell, upsell, then maintenance scheduling, that is warranty analytics, then purchase order automation is the end-to-end automation of the purchase order process. Then healthcare and life science is another area where you can see lots of traction, and you are already aware about image analytics in the same space. So there are three common algorithms used in medical image analysis, like anomaly detection, image processing algorithm, and descriptive image recognition. Also, there are predictive analytics area where it can manage the chronic disease for the patient. It can predict the supply chain requirement for pharmaceutical logistics. It can predict the patient any disease about the patient, seeing the early symptoms. Then genomics is one of the area which is a study of DNA, where data science, you can see the help of data science. Now it is important to combine human intuition with machine learning. So though many people think that machine will do everything, but that is not true. Human needs to perform three crucial roles where they need to train the machine, explain the machine about the outcome of those tasks, and sustain. They need to make sure that the machines are working fine. Also, the smart machines, they can help the human in three ways: amplifying cognitive strength, interact with customer and employees to free up some of the time for higher level tasks, and embody human skill to extend the physical capabilities. And study shows that if you combine machine learning and human capability, the performance will be much better. So I'll pause here. Thank you.
Thank you, ma'am. Thank you so much for your interesting presentation. If the audience members have any questions, then I would request them to post them in the chat box. I would request the audience members to post any questions that they have for Ms. Anjanita Das in the chat box. Ma'am, we will just wait for a few seconds to see if any questions are there.
Yeah, sure.
I don't think any questions are forthcoming here. Thank you, Ms. Das, for this interesting take on the journey of AI and ML. We were honored to have you in this forum today, ma'am. Thank you so much.
Yeah, thank you.
For the next research keynote speech session, I would like to invite Professor Dr. Aniruddha Dey. Dr. Dey is a member of Institute of Engineers India and IEEE Computer Society Technical Committee on Learning Technology, and he has published more than 5 research papers in reputed international journals and more than 12 papers in international conferences. He is a PhD in Computer Science and Engineering from Jadavpur University, Kolkata, and his research interests include face recognition and detection, machine learning, and image processing. He has also handled one R&D project from IEI India. Now I would request Dr. Aniruddha Dey to start his speech titled Feature Extraction and Fusion Techniques for Face Recognition.
Okay. Good morning, everybody. Is this audible?
Yes, sir, it is audible.
Okay. So myself, Aniruddha Dey, I am presenting today feature extraction, basically feature extraction and fusion techniques for face recognition. It is applicable. Feature extraction is very important part, and also face recognition techniques and fusion techniques is also very important for in image processing area. Okay, so why I am applying the feature extraction and fusion technique in face recognition area? Okay, so why face recognition is needed? That is very important. At present, one need a PIN to cache from ATM, a password for the computer. It doesn't to other access internet and so on. Although very reliable method of biometrics person identification exists, for example, finger analytics and retinal or iris scan, and all these methods are cooperation of the participant. But whenever face recognition is incorporated, there is no without participation or cooperation of the knowledge. Okay, so challenges in face recognition. Number one challenge, that is the image used in face recognition highly variable because individual appearance, facial expression, facial hair, makeup, and so on. Number two challenge, that is the light, background, scale, occlusion, and parameter of the acquisition, that is also challenge for the face recognition. Now I will directly goes into the techniques which is done by me and my co-authors also, fuzzy based feature extraction technique for face recognition. So in this case, that is we are familiar with the FLD based method, and some researcher also developed for the 2D FLD method. That means FLD method is incorporate, there is some row direction and column direction. But in this case, we and our research team also develop some generalized two-dimensional features linear discriminant. That means there is some incorporation of fuzzy membership value. Then nextly develop some weighted fuzzy generalized two-dimensional linear discriminant method, and finally fuzzy and Gaussian distribution induce. That means there is two membership function here incorporate. That is the fuzzy and Gaussian membership function also incorporate into the you can say that is the inverse Fisher's linear discriminant analysis. Okay, so I am here using the classifier, that is to conventional classifier radial basis function neural network, and in my next work I am also applying SVM support vector machine. These are the very renowned classifier, and K and K nearest neighbor, there is also very renowned classifier for classification method. So feature extraction method, first of all, I shortly describe that in this case, there is the membership value, fuzzy membership value, there is the fuzzy membership value that is denoted by mu Ci, that is the mu, that is the membership value. It is incorporated into the class-wise image, and for the also the all class-wise image and within class-wise image. That is, all class-wise image is denoted by M inverse, and within class-wise image is denoted by MC. So after that, whenever that is incorporate the membership value in global mean image and class-wise mean image, and after that we are finding the linear transformation, that is the very popular and familiar linear transformation method, that is the ZF is equal to UF into X. X is the image. Okay, so X is the image. So here we are incorporating the membership value into there is two scatter matrix, within class scatter matrix and between class scatter matrix. Within class scatter matrix is defined by row wise and column wise, and as well as between class scatter matrix is defined by row wise and that is column wise. Okay, so after that I incorporate this within class scatter matrix and between class scatter matrix, the fuzzy value is incorporated there. using global and local class value. Okay, and after that we are finding there the two alternative features criteria. The two alternative features criteria, that is JU and JV. That means column wise direction and row wise direction. We find the features criteria by using the projection matrix. Okay, and in this case we are try to find the more relevant features from the facial expression. You can apply this type of feature extraction technique in any image processing application. I also included, there is some weight function, which is weight function that is generated and incorporate into the directly incorporated into the objective function. Number one, the objective function, that means that is the beta weight function, that is which I lies in between the beta. That means the that is zero point 0.5. If you are given 0.5, and the rest of the amount, that is 1 minus beta, that is 1 minus 0.5. So if I give here 0.3, so the remaining part, rest of the part, that is 1 minus beta, that is the 0.7. So incorporate this type of weight into the objective function. So by using this type of value, you can generate more discriminate features. We are trying to find out the more discriminate feature that should be discriminate, and these features you should put into the neural network. It may be RBFNN, it may be SVM, it may be KNN, it may be the recent trend, that is the deep learning technique. There is also some neural network. Okay. So in this case, next, the value, that is the fuzzy function, I have already incorporated, but Gaussian distribution membership function I incorporate in the Gaussian distributed induce function, that is denoted by tau ci, and this is also the membership function. And this membership function, that is denoted by GM, Gaussian membership function, that is denoted by GM, and that will be calculated by using some formula that is very renowned formula for the Gaussian function, Gaussian distribution function, probability distribution function. So that is incorporated into directly in the within row within class, and that is also incorporated with the column within class. That means basically within class matrix. Okay, we are not incorporate here, that is the between class matrix. In Gaussian induced function, that is incorporate here the within class matrix. Okay, and try to find out the more discriminant features from the facial expression or any image related domain. And in this case, we are trying to find out the inverse features criteria. For inverse features criteria, we are included here, that is the minimum value. Whenever only features criteria we are finding, then we are find that is argument max value, that is the reverse portion of this thing. That means in upper portion, that is fs gprb divided by fs gprw. Okay, so this is the inverse reverse criteria, and we are trying to find out the more discriminate features. This is the main objective, and here we are applying some related database which is very common, that is AT&T phase database, that is very common in the UMIST phase database, and that is very common with the FEDET phase database, and try to find out the recognition rate, average recognition rate in different set. In AT&T there is divided the training set and test set. There is training set, that is S is equal to 3. So remaining set, that is the test set. And try to in neural network, there is the basic concept. First of all, we train the data, and then actually test the data and try to find out what is the recognition rate. So this is the concept of neural network. Maybe SVM, RBF, and KNN, but all are same. So try to find out the result which is more accurate three feature extraction technique. That is the technique which is relevant to the FLD based technique. That means feature linear discriminant technique. I only modified, and our group only modified the features linear discriminant analysis technique only features linear discriminant analysis. Then after that, this part I emphasize with the fusion technique. There is some fusion technique. There is some fusion technique. There is the image level fusion. Fuse means add. Fuse means append. Fuse means that means whenever you are adding something. Okay. So there are some type of fusion, that is image level fusion. There are some type of fusion, feature level fusion. There are the rank level fusion. There are the abstract level fusion. There are the decision level fusion. This kind of fusion are there. First of all, I try to incorporate image level fusion. What is this image level fusion? Image level fusion has become to widely use the technique for increasing the clarification quality of the image. So in this case, we are trying to incorporate. Look, the image, facial image is like this. Okay. So we are trying to take the image. If you are convert the image in matrix form, that is the image processing is basically I am doing this using the matrix form. So we are taking the image in this way. That is the H11, and put here H11. Next, I am taking H21 and H12, putting here H21 and 12. Next, H31 and H22 and 13, putting there. And we are constructing image like in this dimension. And that the dimension of the image, that will be much better. So for the dimension of the image, reduce the dimension of the image, this one that will be incorporate here. That means H11 is incorporate or put, you can put here, sorry. That means H11, that means H41, H32, H23, H14, and H11. Next, H31 and H22 and H13, that will be shifted one coordinate. That means H31 that is shifted there, H22 shifted there, H13 shifted there, and these two things are incorporated here. So the final matrix is like in this way. Okay. So in this stage, you may call that is the intermediate image. And if you resolve the black portion and try to find out the original image, but there is although some noise part, because in the image there is no concept of noise, but in that image there is the concept of noise. Okay, so let it be try. That is the horizontal direction we are taking the image. That is the horizontal direction, and again we are taking the image the vertical direction. That is the one image we are taking. That is the one image in matrix form, and we are joining the two image and taking in like in this way: 1 1 2 2 3 3 4 4 5 5 6 1, and put this thing in that direction. 2 1 2 3 3 4 4 5 5 1 6 2. Then put it in this direction. 1 3 2 4 3 5 4 1 5 2 and 6 3. That is in this direction, and image is reconstructed and in like in this way. So I am firstly I get the horizontal image, and that is the vertical image. That is you can say that is the resultant diagonal image, and that is the resultant vertical image. Nextly, you can fuse, that is the one over another, side by side, and truly fuse. So look at the image. First of all, the original image, then that is the diagonal image, that is the resize image, then fuse these both two images, that means A and C, and put fuse this image. And whenever you are fusing this image, you are getting the resultant image, and after that the resultant image constructed by contrast enhancement algorithm. Contrast enhancement algorithm is very popular and famous algorithm in image processing. Okay, so there is another method, that is the superimpose method, that is the original image, that is the horizontally fused, and that is the vertically fused, and after that that is the superimpose, horizontal and vertically superimposed, and there is side by side and original diagonal, that means the horizontal diagonal and the vertical diagonal fused side by side, and that is the up and down. So after that we are try to do the performance evaluation of these three method within some feature extraction technique, that may be a very popular technique, FLD based technique or fuzzy based technique. It may be applied in any technique, okay, any feature extraction technique. So I emphasize here the basically what did you mean by the image level fusion. So here I try to incorporate the image level fusion. So this is experimental result for the AT&T face database. This is the experimental result of the UMIST face database, experimental result for the Ferret face database, and I am using here the classifier as a RBFNN, that means radial basis function neural network. After that, I am doing here fusing discriminant features. Now that is the feature level fusion, that is the emphasis here, feature level fusion. So original image and diagonal image, that is the two images there, and we are extracting feature by any feature extraction technique. The method is that is important, and get the feature based value from the G2D based FLD based technique, and get the feature value, that is P into Q. And similarly from the diagonal image, get the feature value, that is P into Q. And after that we are fusing the image. That means first of all we are write the image, that is G2D based FLD based method, then write the image, not image, that is the feature value of the image, that is the G2D FLD based features of the diagonal face image. Then the fused image dimension, that is 2P asterisk Q. After that, again we are applying the G2D DFLD or PCA. We are taking also PCA, principal component analysis, and 2D FLD based method also. Okay, so here we are also trying to find out where is the best performance result, G2D based FLD method and G2D. That means we are first applying G2D FLD method, that means generalized two-dimensional FLD based method, and then again apply G2D based FLD method, that means G2D based FLD, G2D based FLD method, and secondly apply G2D based FLD method and PCA method, principal component analysis method. So principal component analysis method and G2D based FLD method, and try to find out which one is the more accurate, or which one gives better result for in AT&T face database, in UMIST face database, that is the Ferret face database. And the next part, that is the ranked level fusion method for the face recognition. Okay, so in this case we are directly goes into the picture, that will be clear for you. There is the three feature extraction technique. Any three feature extraction technique, that means it may be PCA, it may be G2D based FLD method, fuzzy FLD method, maybe textural features, that means LBP, that means LTP, SIP, SARP, and after that we are put here for the classifier. The classifier is the SBM. SBM is the classifier. We are taking here three classifier. That's all. That means SBM. We are taking here RBF. We are taking here also the that is KNN. And for the SBM, there is the whenever we are taking the SBM, the output value regarding the class value. Whenever the raw SBM value, the output value, which one is the bigger respect of the class, this is the winner of the class. This is the winner of the class. This principle is follow for the SVM as well as RBA neural network. You are also familiar with this neural network. No, so here we are incorporating some fuzzy rank and try to overcome the related proposed method. That is the weighted board account method, which is published in very renowned publication, and nonlinear. That means related publication. It is in IEEE transaction, and we are proved that our method, that is whenever we are incorporate fuzzy rank and some Gaussian value into the rank level fusion method, and we are try to prove that our method is more efficient rather than the relevant method. Okay, so in this rank level fusion, there is publication, is very good publication, that is the information fusion, very good publication we are published here. Okay, so in this rank level method, we are try to incorporate here the fuzzy rank, that is the fuzzy rank method, and the confidence factor. Confidence factor means which is the output value, which is the output value of the classifier respect of the rank. That is called the confidence factor. We are taking that is a confidence factor. Okay, so by using this confidence factor, we are finding the fuzzy rank, and then after that we are multiplication of the fuzzy rank and the confidence factor to try to find out the class value, which one is the winner class. So I think this was a very innovative method, which is published in a very good journal, and this work is also implemented in some few databases, that is the AT&T database, UMIST database, FEDET database, and all relevant database. And we are finding that our proposed method is getting good result, best result. That is the best result. Okay, so these are the rank level fusion technique. And finally, I also incorporate the ensemble classifier for the SVM fusion. That means the classifier, that is the basic concept of ensemble classifier. Previously, I also ensemble classifier, but there is the concept of boosting technique. There is the concept of bagging technique or bootstrap aggregation technique that will be published in IEM conference in 2000. That is IEEE conference in 2017. Okay, so total data set that will be divided into the set 1, set 2, and set n, and we are trying to incorporate here the any feature extraction technique and the feature extraction technique, and then we are applying here the SVM. But before that, before applying there, we are incorporate here the testing image from the boosting technique. That is the very common technique, bootstrap technique, and we are incorporate here the bootstrap technique. Okay, and we are trying to find out our method, proposed method in some related database, that is the AT&T database, and the AT&T database you are taking. Whenever in this method, there is the 5 is the training set, and rest of the 5 is the test set. But in 5 test set, we are here incorporate by using bootstrap technique. L is 3. That means we are trained. We are trained here using 3 and 4. And after that, we are taking the result for the test result, that is 5. Okay, and also incorporate this thing into the FEDET phase database. Okay. So in brief conclusion, and I also now introduce some decision level fusion, by using some Dempster-Shepard theory. Dempster's DS theory is basically based on the Bayes theorem. Okay, and we are incorporate here. There is 2 journal already communicated using Dempster-Shepard theory. Dempster-Shepard theory is basically try to handle the uncertainty. That is the uncertainty handling, and we are incorporating here the decision level fusion. So image level fusion, feature level fusion, rank level fusion, classifier level fusion, and I also incorporate the decision level fusion. And another fusion, that is the abstract level fusion. So I already implemented the database, that is the AT&T face database, UMIST face database, AR face database, Yale face database, FEDET face database, Honda USCD face database, and this is my list of publication are there in Scopus Index or SCI Index Journal, and international conference there is also. Okay, so thank you. Is there any questions?
Thank you, sir. Thank you for your presentation. The audience members can post their questions in the chat box so that Dr. Dey can answer them.
If you have any question, you can write down my mail ID, or you can communicate with my mail onide007 or onidecse@gmail.com. Okay, is there any problem? You can also communicate. And my research area, that is face recognition, and recently I switched my research area in satellite imaging. Okay, emotion recognition is also there.
So, sir, you are working on multispectral data, right? If
Exactly.
it's a satellite.
Now I'm switching, collaborating with ISI Kolkata.
Okay, sir. Thank you, Dr. Dey, for this informative session on face recognition. We are grateful to you, sir, for joining us today. Thank you so much.
Thank you, ma'am. Thank you very much.
Now for the second corporate keynote speech, I would like to invite Mr. Shiva Sai N, Senior Vice President, AI Platform for Active Intelligence Private Limited. An entrepreneurial product technology leader with 25 years of experience, keen business sense, a flair for user experience, and passion for hardware, Mr. Shiva Sai N has designed and deployed a wide variety of AI-based products over the last 2 decades, including prediction system for public transport for Singapore LTA, image recognition-based IET detection for defense and homeland security, number plate recognition for Chinese and UK cars at land border crossing, and advertising and content optimization algorithms. He has led conversational AI platform for active AI over the last 4 years and laid the long-term vision for the product and created measurable objectives for the engineering team. He has developed trusted partnerships with flagship customers to understand business requirements, translate them into product roadmap, and design one of the most mature NLP pipelines in the market. So I would request Mr. Shiva Sai N to start his speech on challenges and approaches in designing AI-based conversational systems. It's over to you, sir.
Thank you, Shatabdi. You can hear me and you can see my screen as well?
Yes, sir. It's audible and clear.
Okay. Thank you. Thank you. So good afternoon, everyone. So Shiva here. I think Shatabdi has given a good introduction. I'll try to keep it within the time and in fact a little shorter so that we can catch up on some of the time that we're behind. So what I'm going to do today, right? I'm not going to go too deep into AI technology or algorithms or features and models, etc. I kind of wanted to share my experience on how I found that conversational AI and chatbots is actually a pretty big challenge to, right? Because I'm sure almost every one of you must have interacted with a chatbot one time or the other, whether with banks or or Alexa or Google Voice, etc. So it sounds very simple, but one of the things I realized, I've been doing AI-related projects for the last 20 years, across various domains. Starting from 2001, and I found that conversational AI is very, very challenging. So I'll tell you why conversations are challenging. Okay, so I'm sure right? Languages by itself are complex, right? If you take a language like English or Hindi, sometimes even humans misunderstand when two people talk to each other. Okay. And what makes it even more complex compared to traditional AI applications like, let's say, for example, object detection, object classification, images, etc., is there is a lot of state in conversation, okay, which I'll give some examples, right? Because when two people talk to each other, you know what is the topic you're talking about, and you will ask, are you sure? What are you sure about, right? The other person understands very naturally, but to implement that in AI is very, very complex. I'll give you some examples as well. The
Sir,
next
sorry
part
to interrupt. Hello, sir, sorry to interrupt, sir. Can you please present your screen? Because it just got momentarily switched off. If you can just present your screen.
Let me represent it again.
Yes, sir.
You can see it?
Yes, sir. Now it's clear. Yes.
Okay, so what I think I'll just keep it in this state. I think maybe there's some problem with the full screen version of it. Okay, so yeah, so the complexity is, one is the states and memory I was talking about. I'll give some examples exactly later. And next is sarcasm, right? A lot of times, when customers are interacting with enterprises on chatbots, they can be sarcastic. And sometimes, the bot does not understand sarcasm. And it's still a complex problem. I don't think it's very easy to detect sarcasm. And frankly, I feel that sometimes even humans can't detect sarcasm very easily. The next is training bias. I think a couple of speakers before me, I think they were talking about training bias as well. What happens in chatbots today is they're still trained by human annotators. Sorry, I think somebody else is presenting. Can you see my screen again?
No, sir, not yet. If you can just present it again.
I think somebody else is trying to share in between, so I'm just getting thrown out.
Yes, sir. Yes, sir. That's a mistake. Yes.
Okay, you can see it, right?
Yes, sir.
Sorry. Yeah, so training bias is something very, very critical that is actually affecting a lot of chatbots because, see, there is no good training data available for chatbots for a particular enterprise. Let's say, you are a company like, for example, one of our customers is Axis Bank. If Axis Bank wanted to launch a chatbot, which they did, there is no chat data available that will help them train a good model and then, launch a good chatbot. So what happens is, human annotators in our company, they do actually sit and they synthesize data and they annotate it, they tag it, and then we go live with it. And then we realize that what customers ask can be in a very different style or very different topics from what we expected. So that's one problem. And of course, which is basically the same thing. The next point is insufficient real world data. And final thing is expectations. Okay, I will cover this a little later. I'll tell you what is the expectation problem. Okay, now I'm sure most of you might have heard about Google AI's Meena chatbot. Okay, and I am assuming you've seen it. If not, you can Google for it and try it out. Now this sounded very promising, right? They took a lot of data from public corpuses. They've trained the conversation system so that you can literally talk to Meena about anything. Okay, so you can see that which animal do you like? I like cows. I heard they go to college, and then all these kind of conversations they can go through. It sounds very, very human. Okay, so that's one example. One more recent example is OpenAI's GPT-3 model. They also kind of published a chatbot based on that. Again, it sounds very, very natural. It's almost like talking to a human. Okay. Now, when you see these two examples, right, you will feel that, wow, we have cracked the conversational AI and chatbot problem, and it's all done. But the reality is very different. Okay. We are still struggling to build good chatbots. I mean, after this conference, you can go out, look at a few real-world chatbots on any of the Indian enterprises or even foreign enterprises. You will still see that they struggle with many common scenarios, and if you ask them questions continuously. So why are we struggling, right? There are only two reasons, right? First is expectation. So the expectation, right, is see Google Meena that I showed earlier on, and the OpenAI's GPT-3 model. They are very, very good in general purpose conversations. You can talk about anything. It sounds reasonably okay, and it rarely, sounds stupid. Okay. The problem with enterprises, when you want to deploy a chatbot to an enterprise, they want control first. That means I don't want my Axis Bank chatbot to say anything it wants because we have a brand image to protect. And it has to be exceptionally well at answering my domain specific questions in the way that I wanted to answer. So that is the huge amount of control that they need on responses. So you can't just build a very generic chatbot model with, very generic responses. For example, one of the most common technique I have seen, I mean, there are a lot of companies who have proposed this, is, most companies have a live chat agents who actually support customers on chat. So there are some proposed techniques where you can take these live chat logs and you can train a model that will kind of self-learn it automatically. What is the most common questions? What are the most common answers for that? And then handle real chat. So people have tried that, but again, it's challenging because it's become such a huge model. Because typically a bank will have over 1 year, let's say about 50 to 100 million chats. Okay, you can't humanly annotate that kind of data and verify. Okay, that basically means you don't know when the chatbot will ever go wrong. Okay, so that is pretty much the need for control and expectations of how the chatbot should be behaving. So what I'm going to share now, right? I mean, this is just more of given the background of what is chatbot, what is the limitations of chatbot, or why chatbots are challenging. I'm going to kind of break down conversations into a few scenarios. Okay, so I'm just going to skip through a few slides. So if you see AI for conversations, right? Broadly, the way we split the problem, because we don't want to consider this as a monolithic problem where you have a chat incoming message and I will have to find some model to come out with a response, right? That is not something that is going to succeed because, first of all, you're not going to get real data that is good enough. Second, you're not going to get control of responses because sometimes you want to change one or two responses. There is no way you can ever tune a deep learning model that is tuned on some 50 million chats to respond the way you want. Okay, so we split it into broadly 4 pieces: pre-processing, context awareness, intent and entity processing, which is fairly common. I'm sure you must have seen it everywhere, and language understanding. So I'll kind of present you some scenarios, right? Pre-processing is pretty straightforward. Okay, you can do spelling correction so that your next steps of classification, entity correction, entity extraction becomes very accurate. Okay, and we also do normalization of data. Like, for example, what you see on screen, 500, they might type in words. They might type tomorrow, last week, next Friday, or something like that. Instead of training your core classification entity extraction models with so many variations of numbers and temporal entities, we do pre-processing so that we convert it to exact formats in numbers or dates or date ranges. So it kind of increases your accuracy later on, also decreases your training effort on your model accuracy. The next problem is classification with noise. What happens when humans synthesize training data is they will only train things like block my card is a transaction block card intent. What is my balance is balance inquiry intent. They will never sit and train long sentences like, hey, good morning, I'm traveling overseas, I lost my wallet, so I want to block my card. So first of all, you people will not do this kind of work. Second of all, it is not even recommended because it's going to take far too much effort and you might introduce unnecessary noise. So what we have done for a challenge like this is we only train data on block my card, show my balance, etc. But we train our classification model with self-attention and attention classification, so that even though you train only on block my card and they type long sentences like this, we can actually classify it with very high accuracy what is the intent. Okay. The next challenge that we faced, I mean, this is a challenge that is universal, and this is something that we have cracked using deep learning models. So a lot of conversations, they will type one long sentence. This is especially true in voice because they will not tell you, I want to invest. And then the voice, like Alexa will say, how much do you want to invest? It becomes too much of a nuisance to chat on voice with multi-step conversations. So people who use channels like Alexa or Google Voice, they will simply say, hey, I would like to invest 5,000 in Apple at 760 from my account 6930. So the challenge here is extracting and understanding each of the numbers accurately, what it means, which is the amount, which is the price that I want to invest, which is the account number. So this is something, again, is a separate problem that we have cracked using deep learning models. And this we use TensorFlow here, just to give a very high level information. Now, In conversation chatbot, this is the other scenario that most chatbots will trust. I'm sure you can test this in a lot of chatbots out there. People type in multiple lines. A lot of us are used to conversing on WhatsApp, right? They will simply behave like they're talking on WhatsApp to a chatbot. They will type, I have a card. The problem with chatbots today is it tries to classify, I have a card and what should I do with it? And it will always fail because I have a card is not an intent. It is simply an informative statement. I'm just supposed to take it in and then wait for the next sentence. So this is the other kind of classification we have done as a separate step, where we will say that this is an informative statement. I will keep quiet. I will wait for the next statement. And then I will interpret please block, basically means he meant please block card, and I will proceed with classification and the rest of the process. Now, the next important step also is when not to classify, very similar to the previous one, which is informative. When not to classify is very important. For example, if somebody comes and types show in a banking chatbot, you can't call a classifier and let it classify because most classifiers will end up classifying it to some intent with some fair amount of confidence. Okay, and then you don't know, and it becomes a very bad experience. So you have to detect first whether is it even worth classifying by what we call as fragment detection models. So if we we use multiple techniques. One of them is we kind of see if the sentence is complete. Is there a verb? Is there a noun? Or is there at least a verb? And then once we do that, we also kind of do a comparison with valid domain use cases to see if it is complete in the domain. So if it is not complete, we can also expand it and say, hey, show is not complete. Do you want to show bills and show balance? So this is one other technique that we have to use. Now, the other challenge we have is people try to fool the chatbot. For example, recharge mobile is a valid use case in banking. You want to recharge your mobile, top up your prepaid card, etc. But somebody will come and type, I want to recharge my Tesla. Okay. But the classification model sometimes will simply say, okay, sure, I can help you recharge your mobile because the intent is very close. Okay. Now we have to now detect such adversity in users' input and say that, hey, sorry, I can't help you with that intent. Maybe I can help you recharge your mobile. So that is the kind of experience that you have to build in a conversation system. So I'm sure you're getting the kind of complexity a real conversation system has to handle to actually make it controllable and very, very manageable and natural. Right now, some more complex scenarios are language understanding. Okay, will be more advanced. People will simply say, pay 500 to John and Joe. Okay, now you have to understand it is two sentences. I have to split it, and I have to inherit that 500 is meant for both, and then make it two sentences and proceed. Now, sometimes we will not even say that and, which is a conjunction in the statement. Like, for example, how are you? Please transfer 500. Or they will simply type, show my balance, pay my bill. Okay, no full stop, nothing. Right? This is a typical problem with the most current generation. No full stop, no punctuations in WhatsApp. So we have designed a punctuation model where we can actually restore punctuations, split it, and then we handle it one by one, like two separate instructions. So it's very, very natural. Now, this is some of the advanced natural language understanding that we have built into the conversation layer, because most of you who have dealt with text classification, you would have realized that if you try to do text classification into more than 50 intents or 100 intents, it will kind of exponentially become inaccurate. Okay. So what we do is, because banking domain is vast, and we have literally thousands of use cases in banking, okay, literally. What we do is, we keep intent classification at a very high level. For example, all these sentences here, if they type, it broadly gets classified into a very high level intent, like, installment inquiry, okay? And then we do advanced classification, which is like sub-classification to understand how much is my installment as an amount, how many installments have I paid as a count, and when was my installment is a date time. So what is the response the user is expecting. Now I can also classify the tense. Is this past tense or present tense? So by combining the high level intent, expected response, and the tense, we can exactly narrow down to the use case in banking that we should respond to. Now, coming to the next part is sentiment handling, which is pretty straightforward. There are a lot of output models. I mean, the standard models for sentiment. One of the key things that we recommend in handling conversations is to understand what is the subject of emotion. Because if you say if your service is worse, then as a banking chatbot, you're supposed to respond to it. Okay, I'm sorry for your experience. Can I let you talk to my live agent, or can I arrange for a callback from your relationship manager? Now, this is very important in conversations because negative sentiment doesn't mean anything in a chatbot. Because, for example, I will say I hate Chinese. I mean, current sentiment, right? Now, it is a negative sentiment, right? It doesn't mean your chatbot should respond to it and arrange for a callback. So this is something that is very key in extracting and handling it in chatbots. This is some of the advanced handling that we do today. I mean, we are one of the very few companies who have built a very general purpose model to do this. For example, in a conversation, people say, do you offer car loan? Chatbot will say, yes, I offer car loans. How do I apply for it? Now, this is very natural in human-to-human conversation. You understand that he's still talking about car loan. Then they will ask about what's the interest rate. You know that he's still talking about car loan. Now, the guy might simply flip, how about for personal loan? Now you know that he's talking about interest rate, but for personal loan. So this is a very complex model. I mean, we don't have time to go deep into the model, but you can reach out to me directly. I mean, we can explain to you how these kind of models work. Similarly, in multi-step conversations, we have to detect out of context inputs. For example, when you're doing a fund transfer, you said fund transfer money, and then the bot asks, who do you want to transfer to? You will say to John. And then the bot will ask, okay, how much do you want to transfer? Okay. And then you will say, okay, sorry, I want to check how much is my balance. Now you can't go back and say, sorry, that's an invalid amount. That sounds very stupid. Okay. So you have to detect that when he said, how much do I have? You have to detect that it is out of context, but it is a valid intent within banking. You should go and show the balance, and then you continue the conversation where you left off, just like how your relationship manager will do. So this is our context handling module. Now, just to make conversations a little smooth and a little more intelligent, like your real relationship manager, if you simply come and say, pay my rent, it should understand from your past trends that pay my rent usually means I want to pay 1,200 and the person is Michael Keys, who's my landlord. So this is some of the models that we built as part of our conversation systems. The last thing I'll cover in just another 2 minutes, then I'll hand it over to questions, is question answering system itself. Now, question answering again is a huge different domain. Interestingly, the way we have approached question answering problem is not as an intent classification problem. Okay. Now, this has a lot of background to it over the last 4 years, what we have found in real world deployments that we have done, and we have done over a few 100 million conversations. What we do is, we classify FAQs as a broad intent, and then we have built a completely separate system that will handle FAQs. What we do is we automatically generate variants, because you can't expect customers to come out with every single way of asking a question. Okay, it takes a long time to prepare data, and they might go overboard and it will cause kind of training bias. So if they simply train how can I transfer funds, our model is able to generate paraphrases automatically, like how to transfer money, tell me how to make fund transfer, what is the process to make transfer funds, etc. So this kind of increases accuracy of and the ability to respond to FAQs without having to train with too much data. The next thing is to reduce false positives. Unfortunately, we use, for example, universal sentence encoder, and then we use ANOI index to find the nearest neighbor to come out with the answer to FAQs. The problem with these models is, again, they're all statistical models. And like I said, banks have expectations. You cannot go back with the wrong answer ever. Okay. So what we do is, we use key phrases to lock down and narrow down the candidate answers itself, so that it doesn't go too far off from the overall domain. Because I'll give you a typical example, right? A typical bank can have 10,000 FAQs. Okay. Now, after 10,000 FAQs with variants, it will become 40,000 FAQs. Now you kind of encode this into a model, and then you do ANOI index. You're going to have some neighbor or the other for any question you ask, which is close by. And that is not acceptable. So what we do is we automatically detect key phrases, which are your domain specific words like account. We know account is an account, savings account is a subtype, your children's savings account is a subtype. And we do this automatically so that your false positives go down. That is the intent of this. And finally, we also give suggestions automatically, because sometimes the answer may not be accurate. It may not solve the user's problem in complete sense. So we give the answer, if possible, as much as we can. And then we also give similar questions that can lead on and give more answers to the question. So which is why, if you see, we ended up with a lot of modules to solve just a simple conversation system challenge. Okay, now this is all completely AI models alone. I'm not even talking about the broad middleware that you require to orchestrate the conversations, integrate to the bank, right, and everything. Okay, so this is the complexity of it. The final challenge I talk about before I hand over for questions is, if you have a AI system like this with what you're looking at, something like 15 models, you're not going to be able to have your customers or data training guys to train so many models for every customer, right? That's a nightmare. So one final optimization we did is we kind of did automatic model training based on data that you provide only for a few models. So essentially, if you want to, let's say, for example, UEM, for example, wants to launch a chatbot for the university, all you have to do is come and give us your intent and then, and entities, and give us your in spotter module, what do we call a spotter, give me your FAQs. If you do only these 3 modules, and of course you can customize your profanity for the locale URL. Based on this, we automatically train all the other modules and we generate training data for this, which combines both base data, which we get out of public corpus with some, of course, we have some out of the box corpus. Plus we tune these models with what you have provided for your domain so that you don't have to invest in a lot of training data to go live. So that is what I have to share with you today. If you have any questions, I'll take. So I just thought I'll share how do you kind of think about conversational systems, chatbots, what is the inherent complexity behind it, how have we approached in solving some of these problems, and how can you think about it when you start building your next conversation system.
Thank you, sir, for the wonderful presentation. I would request the audience members to post their questions so that Shiva sir can answer them. Audience members may kindly post their questions in the chat box for Shiva sir to answer them. Let's just wait for a few seconds, sir, so that we can give the... There are a few comments. Very informative presentation, sir.
Thank you.
Don't see any questions here. There is one question: can AI solve household work? Although it's a all-encompassing kind of thing. Would you like to answer that, sir? Can AI solve household work?
I mean, household work is, it is already there, right? It depends on what is the household work. For example, if you see a robotic vacuum cleaner, you're already cleaning your house. I'm sure you must have seen robotic chapati makers. It's one of my friend's company, actually. You can look it up. It's called Rotimatic. It's a very, very popular product in the US, at least. So it'll get there. I'm sure a lot of household work is already there. I think right now I see the biggest thing is, vacuum cleaner is the only thing I can think of. And some of these cooking appliances have come in where a lot of AI is required because, making chapati with robotics is not very easy because, it depends on the dough you use, the weather conditions, the climate conditions. I'm sure all the ladies and the gents who know cooking. I don't know cooking very well, but I'm sure you can appreciate the complexity in making a good roti. So yeah, I think that's definitely there, but it will take some time because I think the biggest challenge is going to be affordability, and especially in India because domestic help is reasonably cheap compared to AI still. So I think that will take some time, but I foresee that happening more in Western markets first, and then it will come to Indian markets.
So, are there any conversational AI chatbots for automating tasks and workflows for enterprises?
Yes, of course. In fact, we have built, if you see, most of our chatbots that we have built is mainly for consumer facing. It's meant to, automate a lot of decision making and, in fact, the process flows itself. Now, See, conversational AI and decision making are two different things. Conversational AI itself does not make decisions. Okay? Conversational AI is only focused on making a sense of what the human wants and then connecting to the right systems to make that task done. Now, that task can be your decision making system. For example, if you see, some of the analytics systems, I think you can look up a company called Bird Analytics. You'll get some good information from there. What they've done, for example, is this is an analytics system with big data, like your enterprise system, you have lots of data to analyze, right? Now, as an executive, you want to go and you want to have a chatbot that says, hey, how was my sales over the last 3 quarters? Okay. Now you have to interpret that question and hit the right API in the big data system and come back with the answer. Now that is a simple part. Now, if you ask a question like, how do you think my sales will be over the next 2 quarters? Now, then you have a decision-making system that will analyze, it will predict the future, and it will come back with a response. So it's two different. So it's not exactly connected to conversation per se, but it is something that people are using. So Bird Analytics, for example, has an interface which is very conversational, but it can integrate to your big data analytics systems to come back with relevant answers and corrections.
Thank you, sir. Thank you for answering the question. And thank you, sir, for this great speech. I'm sure the participants of this conference have greatly benefited from this session. Thank you for gracing us with your presence, sir.
No problem. Thank you so much.
Thank you, sir. Now for our next corporate keynote speech, it is my great honor to welcome Mr. Thomas Petter, CEO, Compress Technologies AG, Steinhausen, Switzerland. A graduate from the University of Kaiserslautern in computer science with minors in ET and business administration, Mr. Petter has worked with German Research Center for Artificial Intelligence during his studies and was one of the first entrepreneurs who received a 2-year startup stipend from the Fraunhofer Institute for Experimental Software Engineering. Inspired by Fraunhofer's success with MP3, Thomas achieved comparable success with his patented innovations for watermarking text-based contents and for secret, inconspicuous communication, which are nowadays being used by companies such as IBM, SAP, Amazon, Intel, Microsoft, Fuji Xerox, AT&T, and many others. Since 1998, his company, Compress.com, has been doing innovative IT product development, plus sales and IT consulting, with a focus on artificial intelligence, natural language processing, computer vision, IT architecture, IT security, code quality, MDA, and development. His achievements are 8 granted software patents in the field of text watermarking, secure inconspicuous communications, and 2 CBIT highlights. I would now request Mr. Petter to start his keynote speech on AI to future programming, versioning, debugging, automation, and RPA. It's over to you, sir.
Yeah, hello all. I'm having a difficulty with my screen sharing.
So you present it. There is an option present now.
Yes, but it doesn't give me the permission to present now. Well,
Hello, Professor Showman.
Yes, ma'am.
Okay.
I think Mr. Petter has some problem presenting his screen. So would it be possible for you to present it?
Yeah, definitely I can. If I will get the slide, then I will definitely help you to present.
Sir, if you can please.
Okay, a moment. I'm using a different browser.
Okay. So are you still having difficulties?
So now I should, yeah, now I'm joining on the second.
Sure, sir. I think he is trying to rejoin the meeting so that he can present his screen. So we will wait for some time for him to join again.
Presenting.
Yes, sir. I think it's working now.
Sorry?
Yes, sir, it's visible. Yeah, you are visible. Yes.
A technical problem. So, hello. I'm presenting AI to further programming, versioning, debugging, automation, and RPA, robotic process automation, or how we as a small company found ways to better solve multiple trillion-dollar problems with a single set of related AI data structures and algorithms. So I'm going to present this content. So one key point is that top companies have the opportunity in times of crisis to set themselves apart from less performing companies during crisis time. That's because complex decisions are required. Many control peer companies are just doing average work, and there are typically also lots of opportunities in crisis, even though it sounds a bit contradictory at the beginning. But now I'm going to show how we are trying to do this. So our goal is, so to say, to find gold in muddy waters. Technically, this means we are trying to leverage a few techniques which only cost a few $100,000 to deliver better solutions to trillion-dollar problems. The many techniques have been avoided by IT people because they are perceived as too dirty. For example, graphs until around 2014, complex debugging, programming RPA or rules for this extraction of elements from documents, code generation, and so on. It was abandoned roughly with Enterprise Java Beans 3. But a small company like ours must focus and leverage nifty small solutions to tackle big problems. So this presentation is about how we did this. Because we don't consider us to be good, we found a market niche where nobody else was looking, basically, using exactly all these techniques. And additionally, we applied deep learning, AI, and data science to these problems. So a first component is a visual programming UI, browser-based, where such programming actions can be assembled. We can do business process management with it. And we can visualize existing source code, problems to data, mapping, some parts of debugging, schema evolution, and so on. Another component that we're using is trace and logging functionality. So we have used such a trace tool like this. On the left side, you see the user interface. On the right side, the UML architecture diagram. Okay. It doesn't go forward. You might know Brewer's cap theorem for distributed systems. This states that out of the three properties, consistency, availability, and partition tolerance, you can only have two. You can only pick two. And that means that distributed database systems and other distributed systems, they can be classified along the edges of this triangle. Like all databases, you can find them on one of these edges here. And I found that a similar model exists in other areas, of, especially in versioning, of data models in APIs, application programming interfaces. There are multiple alternatives for transformations. When you have a source system, its data structures can be versioned from 1 to n. its API can be versioned. Then there are typically transformations to an intermediate format, to a destination format. It just stands for a cascade of transformations. So there could be hundreds of transformations. This is just to show the principle. So each intermediate and destination system also has N or M versions. And there are some push actions typically required, or some pull actions that the destination system pulls data from a system before it. And any kind of data conversions might be required. So this can be formalized like this. And this can be used now to prove the following theorem. And it can be used to mathematically calculate which such transformation.
Sir, you're not audible. Sir?
So you got muted suddenly. You got muted. You suddenly got muted, sir. It's fine now.
Yeah, okay, sorry.
Yes, sir. Yes, sir, you're audible.
This is the possible formalization. It can be used to also mathematically optimize which path to take for such a format conversion journey. And that leads, one can to this theorem that I postulated. I call it CAPS. It stands for code amount low, availability performance high, and storage amount low. These are the three properties that we would like to have. And it also turns out to be a trade-off. We can only achieve 2 out of the 3, like in the CAP theorem, a similar trade-off. So we can either choose a lazy migration, an eager migration, or not focus on migration, but instead program multiple converters. And I'll show some optimizations below. This principle can also be shown like this. There's that you can choose one point in this space here, and a combination of all properties is not possible because this overlapping area is empty, but you can choose one of the overlapping areas, which would correspond to one of the edges here. So that's, in text, this means this, but this is what I already told you. Then we are choosing to use code generation for having these two properties. So no focus on migration, and we do code generation for this. So especially big corporations have to deal mostly with complex versioned records, for example, customer sales and supplier data with changing structure and attributes, and have to track this over time, for example, due to taxation and fraud detection. So then versioned object hierarchies and protocols. So with, for example, a bank, insurance, or so, having 50+ IT systems and 10+ years of having to track the data, so programming such converters manually would require far too much effort. So automatic code generation is taking account of the differences with our approach between these versions using this CAPS principle. So typically each IT system has several attribute changes per quarter, and these changes have to be propagated through all systems with the corresponding conversions regarding all input on all output IT systems. So you can imagine how gigantic that effort is. Additionally, there's a microservice evolution. They are evolving here from local developer machines to end-to-end testing approach over complex systems, and also to a bare metal approach to an environment leasing. So it means thousands of microservices, each with possibly their own data formats and APIs, each versioned. So a gigantic effort. So there's a professional approach to this called data relationship management, or DRM. So this is the original situation here on the left, where there's many transactions which are brittle because if a single change is made, then everything might fail. And also, if a change here is made, then something here might fail, a rule violation and so on. Therefore, the high-end approach is to have a central system managing all these versions and all these dependencies and really continuously validating that everything works correctly. However, that is very costly, and also it needs to be configured and maintained. So it's costly in terms of license costs and adaptation effort. So there's a simpler version that we found that saves costs, which uses the open source component Evro-Tree and Evro-Map, also open source. And this allows it to transform a versioning, a description. So Evro is a serialization format which supports versioning into the path description. So for example, this path A2 is in here, and in this flattened O, this structure of fields and the index structure is encoded. So with this structure, we can easily find the differences by just doing a textual diff on the versioned Evro models. And then we use additionally a code generation approach with the string template library or Scalate or Eclipse Java emitter templates. And this Java emitter templates looks like this. It has a Java server pages like syntax with these tags. And for example, this creates a Java package definition. This creates a Java class. This is an iterator on the template level, and it creates the class declarations with, for example, public static final members. So we use this approach for attribute and name matching functionality across various IT systems. And we use hash maps for this. And also within the same data structure to map between different versions of the same data structure. So we created a JavaScript sub-language or domain-specific language for this to declaratively specify how a source model is mapped here, for example, with an add operation on this attribute X and Y. So they are added and then form this X attribute of version 2 in the target logical data model. And this is specified declaratively so that we can do AI techniques on this. And that we can use it with planning and other methods, and that we can reverse it if it's mathematically possible. So then we use standard attribute assignment also, for example, that this variable set it comes from this Y here in version 1. And we pass this domain-specific language with Java CC and open source library or NLR. And we use JSON path or XPath to just encode the differences between versions. And we leave untouched what was not changed between versions. So this generated code is also optimized for structure traversal so that the actual state while traversing is cached in the data positions where the iterator is currently. We use these Evro-Tree dumps as a basis, and we generate converters from older data models to newer versions of the same data model and also to other models that were generated in the same way. And if possible, we try to do this completely automatically, the code generation. We created a central microservice, a service for retrieving reference and feed data in various desired versions. We have a data mapping and code generation system that was created in roughly a month, and thus saves gigantic costs for all this versioning in big corporations. And we can also use then AI for intelligent conversions, so also reversing conversions, chaining conversions, doing planning based on this. How do we percolate in input information through many IT systems most efficiently? Which converters are available and so on. Then we've got another set of tools. We call it analysis tools to finish projects efficiently. And the key here is that we have automatic instrumentation of code for logging, and that we can write out the logs to databases or log files, and we use data science to identify unusual executions and root causes for bugs. So this way we can easily rescue projects. We can finish them more efficiently than with manual debugging, and we allow companies to earn the return on investment quicker because projects get finished faster. So this looks like this. We have a typical source code here. The source code gets instrumented with trace start and trace end statements to log all parameters and all relevant variables into a log file or database. Then this generates traces of this kind. And then we apply these code quality tools, meaning we use data science, machine learning, AI, and best static and dynamic code analysis tools to find the root causes of failures and bugs. And we use this doing classical data science techniques like finding anomalies, outliers, and so on. So the benefits are systematic and quick identification of each bug, that we are around 10 times faster regarding time and 10 times faster regarding costs. And software costs can be monetized quicker, and you have a quicker time to market. So visually, this looks like this. So this is a normal run sequentially from one step to the next. But if something goes wrong, if exceptions are thrown or so, this typically looks like this. And we can analyze from the trace files or from the visualization that here something is going wrong, exceptions are thrown. Yeah, also based on the variables, for example, that nulls are assigned, but there's also a visual component to it, to seeing that something is going not normally here. And we compare, of course, different runs of the same method, yeah, with previous runs and do anomaly detection that way. So we have schema discovery, path analysis, temporal and interval analysis, process pattern and protocol analysis, yeah, process instance analysis if there's multi-threading, different dashboards, and many more. So we also do anomaly detection, outlier detection, correlation, and so on. So this is an efficient way to find such bugs. And the other approach is to do computer vision. And there's a current algorithm is ResNext, the improvement of ResNet, which works with deep learning. For example, classically it was used for image recognition. So there are different convolutions and dense blocks, poolings, and so on, which can be represented as mathematical matrices, which is shown here, and which then leads to prediction horse. And this, in our case, it leads to prediction that there's anomalous execution. So then we went on to apply this to a different domain, which is intelligent robotic process automation. So this is used in this case here in the graph. This means when one requires interpretation of business knowledge and experience, one has either a complex or a simple process. So if there's not much or no manual input, then one can directly apply it. Otherwise, if one can maybe directly encode a lean solution directly in software. So if we don't have enough training data, we need to learn it. Otherwise, with enough training data, we can apply AI and intelligent process automation techniques. This usually contains so-called robots, but they're software robots, just computer software, which enables the automation of repetitive and rule-based processes, mimics interactions of users, and works across functions and applications. Yeah, and performs these tasks. I'm presenting more on this. So we started with standard RPA, and we're moving to intelligent RPA, which does automatic processing of unstructured data. And we are integrating here versioning also, process mining and so on, what I've shown before. And we are going in the direction of true cognitive RPA. We have 3 levels of maturity there, which, so here the classical RPA, cognitive RPA, which can do some natural language processing, also virtual assistants, as we heard before, chatbots, some intelligent behavior OCR, and then intelligent RPA with artificial intelligence and decision-making support. So the standard schema of process discovery here that we use with computer vision is to record the activity of people, then translate the data, apply algorithms and machine learning, process mappings and recommendations, and then do process selection. So this, for a system, it looks like this. We analyze different systems and the processes that are going on there. So this is now turning towards full cycle automation, and then each cycle typically also means a new version. So having here a process discovery, optimizing and developing it in an IDE, in a studio, then automating it in different forms, attended or unattended or hybrid, testing it on a console, and then seeing how well it works, and then entering into a new version and improving it continuously. So ideally, or documented is such a simple process, but actually executed is typically such a complex process with exception handling, fallback mechanisms, and so on. Therefore, we've added planning at the core. Planning is an AI subdiscipline. This is useful for task automation in RPA, for example, and we use this to let the system analyze itself when it needs to do workarounds, or for the combination of multiple versioning changes, an entire cascade of versioning, as I've shown before. So key concepts of planning are that one has an initial and a desired, intermediate, and final condition or state, and an inventory of actions to achieve this with preconditions and effects, so that post-conditions can be calculated. So visually, this looks like this. For example, one wants to travel from home to a park. The park is 8 kilometers away. One has $20. And this would fail because walking more than 5 kilometers is too hard. So the other alternative is to call a taxi and then pay the taxi driver $9.50 and arrive at the park at the distance of 8 kilometers with a remaining cash of $10.50. So this is how the system can decide itself which path is goable or doable. So that means we are using deep learning in several variations. We are using it to find bugs from logs traces, the first thing I've shown. Then we do it for process mining, also using log and trace analysis. We are using it also for detection of movements of hacker and malware through a network, or from log trace analysis. And this versioning and planning is also used to avoid, generate, and train realistic models. Yeah, especially to detect, for example, these anomalies where exceptions are occurring, where root causes of bugs might be. Yeah, and especially on this log trace analysis, and to avoid overgeneration in machine learning. We also use versioning to not train it on a specific version of a model. Then another important technique in that context of intelligent RPA is to be able to analyze documents. So it's analyzing screen content and documents, because that is what's typically processed. So this is a typical form with different fields. They have a name and a content typically, and then the system is supposed to detect which form elements are where, and to extract, for example, invoice date and total amount. This was recently proposed by Google, how to do this. So they're also using deep learning, like similarly to the ResNext architecture I've shown. Here are different texts, texts that are shown with different positions. This leads to neighbor encoding, and there's different neighbors of this self-attention mechanism, and this generates candidates like this field might be a date, and this field might be a label, and so on. These candidates are generated here. Then there are different embedded candidate positions which are encoded, then combined with field ideas, and the deep network generates scores from this, which would be the optimal overall matching to extract this. So So this is described here in the slides. So I'm wrapping up now. So the key takeaways here: we have several gigantic markets addressed with considerable improvements. So finding bugs through analytics, intelligent versioning of data for corporates, intelligent automation, RPA, IDP, so intelligent document processing, and we can do process mining. We can detect hints of movements of hackers, and we only need a few 100,000 lines of code. We are using a simple UI, open source libraries, graph analytics, computer vision, deep learning, code generation planning, data science, and some other AI, but just relatively few components for such complex systems. Yeah, most of these topics were considered too dirty and uninteresting by most people until now, but the business benefits can be huge. So the learning is that business opportunities are often a bit outside of what is most hyped, and you might have to get your hands a bit dirty to really grasp them. As a startup or small company, this is a good way to thrive in recession times or in times when venture capitalists are hesitant to invest. So then I'm coming to the questions. You can find my contact data here or contact me by email here. These are my social media profiles. I'm happy to connect if you send me invites. So are there any questions?
Thank you, sir, for your presentation. Let's check if there are any questions. I think this question is from the previous talk.
Okay.
So audience members are requested to post any questions that they have for Mr. Petter. They can post these questions in the chat box.
Mm-hmm.
So I have a question. How is this? How does this versioning work for robotic process automation?
Yes, it's using this approach. So RPA has to automate typically dozens to hundreds of systems. They each have their versioning, and so we combine all of this. So our system knows this versioning approach can do code generation, and it can. We try to specify everything declaratively. So how is a target version created from a source version like this? And we try to use planning to automatically calculate this, that there's an add operation, or if it's reversed, then it would become a subtract operation to reverse that versioning. This is how we combine the system, and we use this planning to combine all together. So to say we have system 2 with version 3 and system 1 with version 1. What do we need to do to map from one data structure to the other? So we retrieve such converters using the planning approach. See, there might be some existing converters available, and we choose them. We might need to generate a new one which has a certain estimated effort. Then that is estimated what is the most efficient approach. So sometimes the manual work is required to program some conversion explicitly. We try to minimize it. So, but the overall planning takes care of what is the most efficient way to come to our desired outcome, to integrate different systems with different versions.
Thank you, sir. Thank you for answering the question. If the audience members have any more questions, then they can post it in the chat box. Otherwise, we will wrap this up. So I think we have one question. How difficult is it for a non-programming background student to get into AI and coding? I think it's a general question from one of the students.
Yeah. Okay, there are no automatic machine learning tools. It's called AutoML in short. And there's, for example, all the big cloud companies like Google, Microsoft Azure, and AWS, they have it. And there's also toolkits like H2O.ai, which provide AutoML features. So you basically have to just get your labeled data and then do some auto discovery what might work on this label training data. So the answer is yes, it's possible. But the results are suboptimal. So you can maybe achieve 90% quality with this, but typically not 100% that you achieve with manual optimization.
Thank you, sir. Thank you for answering this question. So I think we can end this session here now. Thank you, Mr. Petter, for enlightening the audience with new insights into this domain. We were honored to have you in this forum today, sir. Thank you so much.
Yeah, thanks. You're welcome. And sorry for the technical problems.
It's okay, sir. It's okay. Thank you so much, sir. Our next speaker. Thank you. Bye. Our next speaker is Professor Amit Kumar Perwa from Manipal University, Jaipur, where he is currently an assistant professor in the Department of Computer Science and Engineering. An alumni of Rajasthan Technical University, Kota, Professor Perwa is an active member of ICE and IEEE. He has been instrumental in enhancing the learning environment in the classroom, academic and professional programs to cater to changing industry needs in a dynamic business environment through a good mix of theoretical and industry training modules. He worked with the academicians to develop and maintain high curriculum standards and mission statements and set performance goals and objectives. He has published more than 20 research papers in reputed conferences and journals, and his research interests are in the areas of algorithms, MANET, network security, and Linux. I would now request Professor Perwa to start his keynote speech on mutual authentication of nodes using session token with fingerprint and MAC address validation.
Thank you, Shatabdi.
So you are audible and visible. If you can just present your screen.
Yes. Am I audible and visible?
Yes, sir, you are audible. Quite audible.
Right.
And
so,
sir, your screen is also visible.
So thank you. Good afternoon, one and all. Welcome you all in this first global conference in artificial intelligence and application. And my topic is mutual authentication of nodes with session token using fingerprints and MAC address validation. So typically, my topic is inspired, and it is the research topic, and it is inspired from the security in the mobile dock network, the mobile network that we can have for any such kind of application that we can use for the emergency purpose. So, how to next it? Okay, just wait. All right. So, towards this.
Sir, sorry to interrupt, sir. The presentation is not visible. I think it's not. You have not presented it.
Is it now?
No, it's not visible, sir.
Wait.
We cannot see your presentation.
Is it now?
No, sir, not yet.
Wait. All right.
Yes, sir, I think it's working now. Yes, we can see your screen.
So, for this topic, these are the contents that I would like to cover to deliver the contents on this particular topic. So, the main content for this topic, that is security and MANET, and we know that security has become an important issue to give ensure a correspondence between the mobile nodes in the particular situation. So the property of the mobile nodes are versatile in nature, and due to this behavior, it is very difficult to manage the security policies in this typical networking. So these difficulties presents a difference for building multi-chain security arrangements that accomplish both assurance and effective network execution, right? So in this particular project work, the mutual authentication based protocol and monitoring nodes that will maintain the access list of the nodes which are authorized to access, and monitoring nodes will as a combination of the hash codes and MAC addresses that I worked on this. So with the combination of the fingerprints file of the user acting and as a nodes, and the combination of both will verify the entity. So it involves the various subsection in this presentation that includes your registration of the users, generating of the tokens, sending messages and receiving messages through various algorithms that we have developed, and the execution of the work that the overall work is developed in MATLAB. And the base work, we compared it to the base work and the proposed work to show the results in the form of graphical user interface. And due to all the strength of the pattern of the session program is further validated using the various online password checking tools. Because what we are trying to do here, we are making the password and the communication mechanism that strong, so that if some particular node like to join the network, then that particular node be validated first, then only that node can join the mobile ad hoc network. So at the end, we presented the result with various entropy graphs and with the improvement in the trustworthiness. So if we go through some of the basic introduction of the mobile ad hoc network, then it is mobile ad hoc network is the combination of nodes which presents in the network communication with other nodes in the network, or with the base station, right? So MANET is the network communication with each other via single hop communication, or multi-hop communication like one-to-one, or many-to-many kind of communication, right? So in MANET, the changes to the topology of the network sometimes results in conflict and disturbance into the network, and MANET, and means if you have a base station, it can be many. There can be many base station into the MANET, and they can act accordingly. And also the number of centers node will depend on the type of application for which the MANET is designed. And if you talk about the typical applications of MANET, then it can be military network, or some emergency situations, or some device network we can use there. And MANET is a wireless network which can contain the dynamic center node, which depends on the application in which MANET is involved. So MANET network we can include like cell phones or different mobile devices that can self-organize, and implies that a network immediately from a particular network of mobile nodes or host networks. And the significant destination of self-sorted of MANET is unvaryingly quality and accessibility, right? So mobile nodes are very limited self-governing figures, and they are equipped with each and every facility that they require for the communication purpose. Like they can work as a sender, they can work as a receiver, they have their own power backups, they have their own algorithms and processing units, so they can process the basic computing and can identify, do some kind of process to identify the nearby nodes. So we have some certain issue as well with the MANET, like MANET is having very limited bandwidth, and that's why it's having bandwidth constraint due to mobility of the nodes. And due to this mobility, there is no fixed topology we can have. In the traditional network, we normally have topologies like star, bus, tree, but there is no such concept in the mobile ad hoc network due to mobility. And there is no center control, there is no server in this. Every node works as a server and a client, because sender and receiver So point to point, they communicate with each other. And then the scalability, we can discuss the scalability. It means that any node in the particular network can join and leave this particular group as per their requirement and their mobility that is set by default as their basic property. And there's one more issue, an important issue that we have is the security because of the mobility and that self-governing body. They are not that much securely equipped, and there's a scope where we can work upon to implement some sort of algorithms so that the nodes can communicate with each other in a more secure manner. So these are some typical routing protocols we have, like proactive, reactive, and hybrid. So these three category only we have. And normally in the reactive routing protocols, it normally work on the graph method based. It means it scan the overall geographical area and they try to find out the routes from source to destination with the best available, or we can say that is on demand. There's no fixed route between source to destination. Whatever the best route, they can find it out on demand. They do that particular processing. And the famous routing protocols that we have under this category is ABR, ECOR, AODV is more popular nowadays, and DSR kind of routing. Another type that we're having is proactive routing protocol, and this is typical and that based on the traditional method and table-driven approaches. Means they in the router they maintain the table of the nearby nodes. So whenever they come into the contact, they try to establish communication with them and transfer their packets to that particular node. And the same thing will be processed at that another end of the node that where this particular data is transferred. So due to this routing, we have several security issues in mobile ad hoc networks. So to make sure that the MANET, one normally thinks about the security, accessibility, and uprightness, legitimacy, and non-disavowals. So privacy guarantee that the mystery data in the network is never overcovered to unapproved nodes. So for example, the affiliations, that information is not revealed in unauthorized node, and accessibility guarantee that the mentioned node administrations, for example, the data transfer capacity and availability are accessible in IDEA, and administration is not denied to approve the particular client. So trust between the node assured that that unmoderated message will exchange between the corresponding net. So this is the overall idea to develop this paper, and the trustworthiness guarantees that the message or a bundle being moved between node is not adjusted or undermined, and these confirmations that the information is certified, and validation guarantees the right character of the friend node is communicating, for example, the information that the node cannot later deny the information was sent by it. And node versatility in the MANET present numerous security issues and powerless against various sort of security attacks than customary wide and wireless network connections that we have because of their open media and dynamic network protocol. So the poorly modeled MANET permits the aggregators for capture the infusion and some kind of correspondence. So with the legitimacy, secure mobile hosts are efficiently caught. And malicious nodes conducts may purpose upset the network with the goal that the entire network will bundle misconduct of the particular node. So based on this, we have set some of the objectives for our work. And in this, these few of them are in this the mutual authentication based protocol in which the MAC address and fingerprints will form the basic of the determination of node, which is the dual authentication based on node identification, right? So this is number one objective that we need to achieve. And second one is randomization of the session for the transfer by the generation of the tokens. And each time the transfer takes place, a new session token is required to be generated to provide the more security in the data transfer for the mutual authentication against the MAC address of the communicating parties will be involved in the process of generating various tokens. And third is about dual security in the data transfer with the generation of OTP and transaction ID for the validation of the receiver. So we are validating each time whenever a new node is joining a particular network. And fourth one is validating the integrity of data received with the generation of the hash for the message received, with comparing it with the hash AND. So keeping it into mind, we develop, and there are a lot of things which motivate us to develop this work. It is due to weak security into the mainnet may cause man in the middle attack can be the big security loophole in this particular network. So dynamic attacks could run the deletion of the messages and sending wrong messages or duplicacy of the node, and so on in the manner breaking accessibility, trust, and authentication, denial of services, and the point to be taken care into the future research is to consider harmful attack for inside and outside into the network to exchange the information by the node. And that mainnet, we know that it is as a dynamic network, and it can be frequently changes its topology. So indeed, even the trust connection among different nodes, like change particular, even a few nodes are seen anonymous. So because of the physical limitation in mainnet, security is an area where a number of research work occurs. And but the dynamic security system is still under process. And presently, the necessary is that the security system should be dynamically and flexible and scalable. So in terms of security, we can also discuss another terms like data authentication or node authentication, because these are the two important key for us to motivate. So one is the data authentication. In this, in a wireless network, an adversary can, without a lot of stretch, use the message or change the message. The recipient need to guarantee that the data used in an essential leadership produce starts from a genuine sources. So data authenticity keeps unapproved parties from sharing in the network, and genuine component should have the option to discuss message from unwrapped rejection them. So measure the guaranteeing depending on scene on essentially for recognizing messages modification and to reject implement messages, right? So in the semantic cryptography, MACs are machine authentication codes are used to give authentication, and the sender and the receiver share a RIDL key to process a message authentication code. And all this data exactly when a message with a correct match shows up, the recipient understand that it is almost certain being sent by the primary sender. So this is how they guarantee the sources. So in the open key cryptography, advanced imprints are used to seal a message as a technique, right, for authentication, and for advanced imprints in numerous arrangements for indicating the validness of the modernized message and records. Then a next term that again motivates us is the node authentication, because node is the primary key in our application, and authentication is is not solely to data trade frames yet in addition to the network administration. It's like to addition a new center point into the network, and a couple of authorities has consulted on the center point authentication before the node join the mobile ad hoc network and any particular network. So such convention replies upon matches conditions and number speculations to the achieve secure authentication among nodes in mobile ad hoc network. And most research is, stretches around this. And there's one more key that user authentication means a node can be a user sometime. So customer authentication or a node authentication is a mean of recognizing the customer and confirming that the connecting node is allowed to get to some rejected administrations. So this is how we can deal it with the user. Apart from, there are so many other factors through which we can identify the particular user, like a biometric or DNA, fingerprints, voice recognitions, retina detection. So there are so many papers that we have gone through to review the particular work, and these are the descriptions that we have. We have more detailed description, but due to lack of time, I created a summary of it. And these are the popular research that is already available, like message digestion or transport layer security or tunnel based or protected like that way. And we proposed a session token using fingerprint with MAC validation after the analysis of this research. So we can separately go through these individual papers that I have cited here. And through this, we have found some of the research gaps based on the analysis of the paper. So this is that there's a new there's some research gap that we can have is that there's no guarantee arrangement that is available for the authentication of source and destination node into the spread plan. And second one is that most of the security instruments are not dynamic. And third one is that the legitimate work of the intrusion detection technique is not yet characterized. And fourth number is that the general framework for authentication of node in mobile ad hoc network is still need to created. So this is what we have. Then the basic concept we have in our proposed method is one-time passwords, because every time a node is sharing OTP to authenticate themselves. So we all know the basic concept of OTP. So OTP that is based on the security device and are the smart concept based on the cards that consist of the chip-based security model, which generates the numerous or even the alphanumeric combination of the characters to validate access to the system or in case of the transaction, right? So the concept of secure chip model is designed in such a way that the generated OTP pattern change every 30 to 60 seconds and the range of the validity of the OTP generated for the particular transmission will range based on the importance of that particular action. So the common application of the OTP is a mobile-based application where a user validates checking using the OTP, and various mail exchange applications like on Gmail, we can Gmail, Facebook, we can see such kind of two-step validation through the randomized generated OTPs. So we have designed some of the basic model through this OTP. So in this, the OTP is commonly expressed as a combination or the sequence of alphanumeric characters, which are used for the verification of the identity of the user or the validity access of the um, uh, transaction on the session. So an OTP is comparatively more precious and secure than that of the static passwords or particularly user-made passwords. Right, so which can be frail or will as reuse over various records. Also, OTP can be used as a medium of verification of the individual user as the time of the login and will furthermore add the layers of security in the process of authentication and validation. So there are some kinds of OTPs that we can have that is like if you heard of UBQs or secure IDs or Google authenticators or some SIP authentication. So these are some popular OTP types, and we have some advantages of the OTP as well. That the single sign-on we have covered already. So advantages we have already covered. Of OTP in this, the main advantage of OTP password is that the user has not to remember any particular sequence of the particular password pattern to access the particular service on the system. Right. So apart from this, we have so many other techniques that we have used to design the algorithm. One is the random numbers. So a random number is what it is the number which creates utilizing a huge arrangement of the numbers and scientific algorithm that gives an equivalent likelihood to all number happen in the predefined distribution. So random numbers are mostly commonly created with the assistance of random number generator. There's a fixed algorithm that we have to generate such kind of numbers. So later on, we can use these numbers to create a kind of cryptographic algorithm or some kind of encryption techniques. So in our application, we have proposed 5 different algorithms for different purpose. So this is the list that we have. That the registration of the users into the network and then the destination of the MAC address validation and generation of the tokens for message exchange on user end, and then generation of token for the sender send, and then we have module for the receiver messages. So I'm just quickly coming on to the algorithm part. So this is the algorithm for the registration of the node. So in this, we are whenever we are trying to communicate from a node into the mainnet, some input we require from the communicating node, like is MAC address and the fingerprint, and as a result, will out the details of the node that we have saved and unique number that generated in terms of particular node registration. So this is the step-by-step procedures that we are following, and this is as simple as that. That first we are reading the MAC address and fingerprint of the user or the node that we are considering as a node. Then we are generating the hash code from the input that we just received as a MAC address and fingerprint, and store it into the particular table that we call SHA FIQ. Then there's another run we are doing it for the hash codes. We are generating hash code the MAC addresses. First process we are doing for the fingerprint, and second process we are doing for the MAC address and storing it into the SHA MAC table. The separate table is created for this. And if we are checking the duplicacy of this, if MAC address exists, then this table reports, and that reports that node already exists. Otherwise, it will save the details of the nodes that it want to communicate. And with this algorithm will be end. And with that we have second algorithm that is for the validation of the MAC addresses. In this, we are taking a destination node number as an input, and we are returning the MAC address of the particular node if it is registered with it. And in this, establishing the connection with the node database that we already stored into the database, and it perform the operation in database for the node. So whenever it try to communicate, then start searching it in the database whether the details is available or not. So if data exists, then fetch the details of the destination node from the database. If it is not available into the database, it simply reflect the messages that that node is not exist with its database, and it will not communicate with that node. Then we have another algorithm for generation of tokens for message exchange. So for message exchange, they are generating the key through various random numbers that I just discussed before. So in this, on the basis of MAC address and destination MAC addresses, they are creating the session tokens. So session tokens are fixed length characters that we are creating through the random numbers, and we are arranging them into the sequence to create a particular key. So 10 runs we are doing here for the random numbers. Then through this we are generating hash codes of SHA-256 for sender MAC address, and extract the first 20 characters from it and store it into the table that name is SSJ sender. Then we are generating code for the same algorithm SHA-256 for destination MAC address, and extract again the first character and store in the another table like SHA destination. Right. So that is how we are combining the random number generation, and these two tables we are combining to generate the session token for the that we will use for the communication. Then we have another algorithm that will work to generate the token for the message exchange. First was for the communication purpose only, and if that particular task done successfully, then we reach here. In this, sender MAC addresses and destination MAC addresses and destination token that we just generated in the algorithm number 3, and we generate OTP and a transaction ID through this particular algorithm. So as a process, we read the senders and destination MAC address, and we use the session tokens to validate the nodes. And if session token, the user who created the session token is validating it, then we perform the OTP through the random number generation, and we then arrange into the sequence and generate a fixed size OTP. And if when we store it and details of the transactions that we have just created, and we generate the SH256 512 algorithm for message and store with the transaction details. So this is just for the OTP and other authentication generation, so that whenever our communication, we are communicating with another node, we can share this OTP for the authentication purpose. And this is for the receiver when a node want to receive the information from the communicating nodes. So in this, sender's MAC address will be validated, and destination MAC address OTP that we have just created an algorithm for, and transaction ID we are using to receive the particular information. And in this message decrypted, and the successfully receipt of the messages will be generated. So here we can see that this is the process through which how we can share the ID and OTP with the receiver, and transfer the data, and is validating it through this algorithm. If it is okay, then it is accept the data, and otherwise if something is wrong, it's providing the invalid details messages to the particular user. So this is the algorithm that we have used, and the simulation environment we use here for MATLAB. And all to practically show it, we have developed so many forms based on the algorithm we developed. So this is the based on algorithm one, the registration form in which a user that we would like to register some mail ID or MAC address, and through it is generating a password, or it is check the record. If it is already saved, it will reflect the messages, otherwise it will register the user. And this is a sample of the fingerprints that we are taking from the particular node. And this is the login form that is related to the algorithm number 2, in which the user detail we have just entered, and the MAC address will automatically fetch from the database if you want, if entry is already matches, and it generates the password for the particular user for which we are creating the login. Then we have user control panel, in which we transfer data after validation, and we receive the data for the integrity check. And at that initial display of the data sending, before sending the data, it first validate the user. So when it will enter the destination node, it will fetch the destination MAC address and validate it from the database. So if it is validated, then it will generate the session key and OTP. Right. So like that way, the session key is generated. And if it is it's matched with the database, it will generate a session key for to establish the communication. That session key will be exchanged in overall communication. And the process of generation of OTP, and receiving data, that if data fetched successfully, it will reflect the messages. So this is the internal forms that we have created to develop all the overall algorithms. And after the algorithm that we have developed, we have tested it on several tools to check the authenticity and the security of our algorithm. And this is the method we call it entropy. So entropy is the method in which we check the security level of any password that we have created. So here we have created the password through various security techniques, in which OTP or session key or some lot of validation codes we are using. So here we run it several times, and the blue one is showing the base key score, and the orange one is showing our proposed key score. So it is showing more efficient in terms of the secure password, or in terms of the length of the password. So this is one tool that how secure my password is, there it is tested. Then there's another tool here, again we found it successful. This is run team test, and tool number 3 is a crypto tool, and tool 4 is how secure my password is. It is here again, it's showing good results in terms of a good password generator that we can exchange to the another user. So overall conclusion that we found here is that the security has become the essential tool nowadays. And almost every application we require such kind of algorithms. So we have successfully created the algorithms, and we have tested it on the renowned tools where we have checked the entropies and new authentication based scheme designed specifically for the minute nodes in the proposed algorithm. And the main purpose of designing such an algorithm is to provide a strong trust-based authentication mechanism for adopting the topology that is often changing like in such a mobile ad hoc network, right? So this is what, and apart from this, in this particular algorithm, it involves the various subsection that includes that various forms, and we have created a lab environment for this. And to enhance the base work and proposed work is finished by structuring the successful result that I just shown you here, right? So as in future work, that what we can do is we can do the improvement, a lot of improvement into the security methods. And this time we can think that we can take DNA-based security and retina-based security into it with the associativity and with the user that we are considering as a node. And these are some of the references that I just taken to create this particular research. So this is what I would like to present. I will be happy to answer any question if you have.
Thank you, sir. Thank you for your presentation. If audience members have any questions, please post them in the chat box. Sir, let's wait for a few seconds to see if there are any more questions.
Yes.
Audience members are requested to post their questions in the chat box for Professor Bhargava to answer. The audience members can kindly post their questions in the chat box. So there is a comment, sir, from Dr. Narmada. It's interesting work.
So thank you, Dr. Narmada.
If there are no more questions, then I think we can proceed. So thank you, Professor Bhargava, for delivering an interesting speech. We were honored to have you in this forum today, sir. Thank you so much for sharing your research with us.
Thank you, Shitab, and thank you all for
you,
listening. Okay.
Thank you.
Thank you.
With this, we reach the end of the keynote speech sessions for day 2 of GCAIA 2020. I would like to inform the audience members that paper presentation sessions will start from 1:30 p.m. today. Respected delegates are requested to join the Google Meet links provided in the conference schedule. Thank you all for joining today's session of GCAIA 2020, and we look forward to your presence tomorrow as well. Thank you so much. Professor Shome?
Yes.
Sir, I think